Thank you, sir. So, very good morning to one and all here. So let me quickly share my screen. Uh, just a quick heads up. So everyone, is my screen visible to all of us?
Yes,
Yes?
yes,
Yes,
it is.
Okay, perfect, perfect, sir. And I think I'm audible as well to
Yes.
everyone.
yep.
Right? Perfect. So actually, for this aspect, right, for the sessions, for the last few sessions, I have taken up a little bit of a different approach. Okay. So the idea here, which we are going to probably talk about, right? Let me, I hope the PPT is visible to all, right? Hopefully. Um,
Yes.
yeah, perfect, sir.
Yes, yes.
All right. So, so very good morning to one and all here, and welcome back to the session again. We have, I think, more or less, everyone would agree, right? I mean, now we all have become. I mean, that's the whole idea here, right? Now, a little bit of a giant, right, in terms of understanding these concepts, thanks to our series of sessions by various trainers, right? So recently we had Aditya sir until yesterday with full a lot of elaboration on how things work out and what happens and stuff, right? If I talk about in the context there. So more or less, I think uh, we are aware of the context which we are talking about, right? So my efforts, right, if I talk about, right, will look into the context in a little bit of a practical manner as well. Okay, so whatever we have seen so far, right? I mean, I'll show you the things like what it means to train these. Okay, I mean, what happens and all of those things, right? We've seen a lot of mathematical aspect, a lot of, if I talk about, right? So each and every aspect as to how things internally work out, right? So more or less, things are particularly understandable by all of us, right? That to how the things work out in a little bit of a elaborate sense here, right? So the idea here is, right, to talk about, right, how these machines are actually trained, right? If I talk about, right, and I think more or less you can justify the context there. It shows says giants, right, in the context that because these models are huge, right? They have huge implication to how the things work out, right? So and obviously and if I talk about, right, the idea is to look into chat gpt or the gpt based models, right? If I talk about, or the gpt class of models, right, and llama as well, right? So if I talk about in the context, right, so we'll look into few of the context, right, and how they work around with the context there, right? So if I talk about, and now I think more or less everyone knows this picture. It is pretty, what do you say, basic, becomes basic now, right? A little bit in the context, right? What is like basically the idea of a transformer, right? If I talk about in the context, right? How many of us have seen the Transformers movie, by the way?
Yes,
Anyone?
sir. Yeah, yeah.
Yeah,
Yeah,
seen, right? Yeah, perfect. So I think that's nice, Ankit sir, and the others. That's brilliant, sir. So actually, you see, I think this recalls you Optimus Prime, right? You see that face mask there, one of the key characters there. If I talk about, right? Uh, So, with this motivation, let's move to the next. If I talk about, so to give a overall idea, right? If I talk about the entire thing, right? The entire series of things which we are going to conquer, right? Has been actually, let me bring out the pen here quickly for quick uh, overall context. Let me see. Right. So just to give the context here, right, to set the ground, right, the ground rules, okay. So we are going to conquer it in three different phases, okay. So you see this, the phase one, which talks about the pre-training or in the place where you start off, right, the training phase of the models, right, if I talk about, right, followed by phase two, which we will be looking into SFT a little bit, okay. Uh, Anyone recalls the full form apart from Aditya sir, because Aditya sir taught you about all of this. What is the full form of this? Anyone? P2 will talk
Could you
about
please,
SFT. Sir,
could
I'm
you
asking
please,
about, yeah. The question is, what is the full form of SFT? What I've written
is it
here.
softmax or something?
No, sir. Okay, that's good. I'm happy that you gave a
Supervised fine
creative
tuning.
thought. Uh-huh. Yeah, exactly. Perfect. So this is stands for supervised, right? Fine tuning. Okay. Perfect. That's brilliant, right? And followed by the third phase, right? Yet another, another milestone which has led to the success of the Transformers network, if I talk about, right, is called as anyone? Any guesses? What could the phase three will be dealing with? Any guesses? Anyone? Any? This is open to everyone, as a matter of fact. What do you think? I've talked about this is before, I mean, if I talk about, right, the training phase, right, if I talk about, right, this is post training. What is remaining? There are three phases, I said. This one is the phase one, which we'll look
Loss.
into. Okay, so actually, a loss is part of the training itself. You'll see all of those things. Nice. I'm very happy, sir. You attempted it. That's great. Yeah, loss is the loss calculation and everything. Back propagation is part of the training phase itself during the time of training. So everything happens in that, right? The third most important aspect, because of which you feel like, okay, I'm not talking to some kind of a random robot, but it is something which is maybe acting like a human. Can anybody tell me that factor? The part three, the third key domain in machine learning.
Reinforcement learning.
Yes, 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 exactly. Frankly speaking, just like Adarsh has mentioned, specifically, it would be RLHF. That means reinforcement learning with human feedback. Okay. So we'll talk about that a little bit, right? I won't be boring you a lot with a lot of formulas and everything. We'll talk about the gist of it to understand what is going on and stuff, right? But however, it will give you an overall picture about what we are talking about, okay? So phase one, we have the pre-training. This, in fact, under the category of post-training, I should have taken it in the context here as, right? P1, right, completely comprises of the pre-training, right? If I talk about, right, in the context of, or if I talk about the training phase in the context of how you train these machines, right? P2 and P3, both of them, right? SFT as well as RLHF, right? Both of them come under post-training, okay? Or in fact, I should say inference, right? Now that we are aware, everyone knows about this term, right? What is inference mean in terms of, I'll be a little bit technical. I'll use those words, okay? The word inference, right? I'm sorry. RENCE. What is it? Anybody? The inference step, what is it? Anyone? Training. And so that basically the entire thing is actually divided into two categories, that is training and inference. So anything which you basically inference
Predictions.
simply, yeah, exactly, sir. When you apply it, Inference is once you have trained the machine perfectly as iterated by Jaisar, right? Once you have trained the giant machines and everything, right? You go to the next step called inference because now you have created it, right? You want to use that. Basically, the idea is you want to use that model to make predictions, right? The word predictions, which has been mentioned by Sir, right? So more or less, the terms don't differ, right? The fun fact is, right, whatever you have seen in machine learning or deep learning and stuff, right, the terms are relatively the same, right? You do the same kind of a step here, right? It's just that it's the interplay of words. So if I talk about in the context, right? So more or less, I think these things are pretty clear, right? Phase one, which is comprising of the training phase and stuff, right? Two and three phase, if I talk about SFT followed by RLHF. Okay, so we'll look into it, right? And we'll talk about it a bit. Now, let's move forward and talk about the next important aspect here, right? So, if I talk about here, right, the word decanting the web, basically from chaos to corpus, right? So, the very first step, right? What do you think, guys, is the very first step when you start off with the, forget about transformers, right? Anything, right? Whenever you work with, right? What is the most important step, the very first step which you do in these cases? What is it? Anybody?
Pre-processing of data.
think
Uh,
we may do
so
some web scraping.
Yeah, exactly. So the very
Yes.
first thing, sir, if I talk about, Aziz sir mentioned it rightly, it would be a next follow-up step. But Aman sir, as said, as I iterated, right? The very first thing is you extract portions or data from the net, right? Or the thing is that's what we call as corpus, right? And in fact, the way forward is from chaos to corpus. Chaos to corpus in simply means that chaotic content would be anything and everything which is available on the internet, right? But anything and everything is not useful for training our systems, because if we train it on anything and everything, right, suppose there are dialects of slangs, right, which it has seen during the training, right, those slangs will tend to appear in the entire, I mean, the inference time. Is it understandable, right? Or maybe some kind of adult content you have, right? If I talk about, right, you don't want those things to be part of it. Some kind of hacking based systems, if I talk about in the context, right? Unless and until it is not under the domain or the umbrella of ethical hacking, right? So that's the whole point, right? So what you do is fabricate. So it goes through a process, I mean, refinement process, right? You have that raw stuff all going through, right? You know about, everyone knows about crude oil, right? Crude oil or petroleum, right? Everyone, if we know about, right? From the petroleum, which is a black thick liquid, right? I mean, which is found under the Earth's crust, if I talk about, it goes through a series of refining process, right? And at the end, you get diesel, maybe petrol, maybe kerosene, and other dialects, if I talk about, right? The idea here is pretty very simple and straightforward. It goes through that entire series of process, right? And at the end, you get the context which we are referring to here, right? So it goes through a series of refinement, right? So the raw data which is available has to go through a lot of filters. So we call these as filters, right? So I think more or less you understood this, right? The step one, download and pre-process the internet, right? If I talk about, right? So before training LLMs or the large language models, right, we must gather massive volumes of human generated text, right? This include may not be only limited to, if I should say that as well, right? Wikipedia articles, right? You have, let's say, news websites, Stack Overflow threads, Reddit. You can see these, I mean, these icons. I think these icons are familiar with the people here, right? If I talk about, right, Wikipedia followed by this Stack Overflow, this Reddit, right? GitHub, you have different sources from books and stuff, right? If I talk about in the context, right? You acquire from different sources, right? Now to show you a sample, right? I want to show you how the things actually look like and the context, right? So, just to give an example here, we begin by downloading and cleaning the internet to create a very high quality training data set, right? And one of the examples, right, one of the very popular examples available on the internet, if I talk about, in fact, that is open source, okay, is the Fine Web data set by Hugging Face, right? Hugging Face, I think Sir also had shown it to you, right? If we recall, right? Aditya sir had given a small demonstration about Hugging Face, a place where you find different kinds of codes, data sets. You can talk about different models and everything, right? So you find it there, right? So Fine Web is hosted on Hugging Face. If I talk about, right? Let's go to that and talk about it, right? So let me click on this. This is a clickable link. And by the way, let me also share this very first link to all of you, just in case, right? We want to have a look. Please feel free to go to this website, okay? So I hope everyone got that there, right? So the very first place, right, where you talk about this, one of the data repositories, right? But this, you can see it says fine web, right? Meaning the web is fine-tuned or filtered with the proper data set. It's not the raw form of the data which has been collected, right? Okay. Let me show you a little bit. By the way, these individual points are, they are all what you say, navigatable, right? If you talk about, you can see that there are clusters here, right? You can see the technology cluster here, right? There's the scholarship cluster here. There is politics cluster here, right? So they are all clustered into the data which has been acquired from different sources, right? Theology, right? If I talk about philosophical or spiritual introspection, right? If I talk about, so different kinds of stuff, right? Hosted. And in fact, this data set, the Hugging Face, the Fine Web data set, right? Let me show you how big it is. You can see here, right? It shows 15 trillion tokens, right? In the context of the Fine Web data set contains 15 trillion tokens, which is approximately 44 terabyte of disk space, which is needed in the context of working around with it, right? And that's a huge number, right? 15 trillion is like 15 into 10 to the power of 12, if I talk about, right? So that's a big chunk of data which you have which Fine Web has what do you say, fine tuned over the years here, right? So let me click on this, right? On this particular link here, it will redirect us to the data set. Okay, you can see huggingface.co, you have the data set here right now. Under this context, right, let me just do this, right? Yeah. So you can see here, guys, everyone, right? Can you see here on the right hand side the size of the downloadable data set files? If you talk about, right, in the context, it is 108 terabytes, right? I mean, that's a huge amount of data which we talk about, right? And it somewhat looks like this. If I talk about, it's just a subset. It shows you here, right? You can see it contains 25.9 billion rows, right? B is the billion, right? If I talk about, right? And let me just go to one single of them, a smaller chunk of it, right? If I talk about, right, now in the context here, right, you can see like how it looks like, right, after refinement, by the way, right? If you look into, let me click on any one of it, right? Let's go to the first one itself. You can see that this particular passage maybe some kind of like you can see, right, it talks about tornado, right? So some passage on tornado it shows, right? If I talk about, right, and also it is dumped into this particular what do you say, by the way, you might be looking into this word here, CC, right? It is nothing but common crawler, okay? Okay, I think more or less you can understand. Do you know what is a crawler, guys? Anyone? Do you know what is a crawler? Sorry, sir, I'm unable to
Basically,
hear
it is similar to web scraper,
you. Yeah, exactly,
but it is
exactly.
used to store in some databases, I guess.
Okay. Perfect. Perfect. Excellently said. Yeah. Someone else was also trying to attempt. Anyone else have any other thoughts? Anyone? Perfect. As perfectly iterated, you guys are actually correct about it, right? A crawler is what goes through a website, right? So and takes or extract portions of the text and feeds it to a database so that it is stored somewhere to further use, right? So that is why, in fact, there's the by the way, CC stands for Common Crawler, and Common Crawler is a company, by the way. Okay, we'll look into it. Okay, don't worry about it. We'll come to that as well, right? But as of now, you can see that this is one of the what do you say? Data which you can see, right? And the first data, it seems to be about tornadoes, right? If I talk about, right? And you can see that there is a URL, right? It also tells you which URL it has been extracted from, right? And let's go to the right hand side a little bit, right? If I talk about, you can see they have mentioned the language in which it has been the content has been extracted on, right? So you can see the language as English, right? So the content, meaning the web page, is containing the language English, right? And generally, during the time of extraction, right, these crawlers, when they visit the different websites, right, these guys, or maybe companies like common crawlers, right, or if I talk about, right, in the context there, right, or in fact, what FindWeb has actually done, right, that they use something called as a language score, meaning they even suppose the entire thing, or suppose the content which they have, what do you say, suppose they have collected 100 pages of data. Okay, just to give you an example. Okay, suppose crawler has what do you say, collected 100 pages of data, and out of these 100 pages of data, suppose, let's say, 20 pages, right, contain, what do you say, Spanish. Okay, contain Spanish data. Okay, so because they do crawling on these website on I mean they have a initiated seed value, by the way, right? A random seed value which they take, right? Okay, and that random seed value, whatever the values come up as, right, it goes forth and goes into that particular website and takes the chunk of the data and stores it. Okay, that's the whole idea of it, right? Now the idea here is, right, if 20 pages are containing Spanish language, right, mostly Spanish, right, what these companies like, I mean, if I talk about what these corpuses like FindWeb actually does is, if I talk about, right, they set a benchmark that, suppose, let's say, 50% more, if the content of the website is containing more than 50% English, then only be a part of it. Did you get it, guys? Are you understanding? They set these standards beforehand so that it is containing lot of English text. And suppose, now let's say, there are few the 20 pages completely uh, containing Spanish. Okay, suppose there are 5 pages which are containing, let's say, English and Spanish mix, right? Somewhere you see translations and everything, right? So what if they have 50%, meaning they go through each and every page, right? Okay, and they see that more than 50%, like 3 lines, more than 50% of the content is, let's say, I'm just saying, a benchmark strategy. So many different companies use different strategies. Some companies may use 75% as the benchmark, meaning each go to each page and see if the content is 75% in English, then only extract it, else discard it. Is it understandable by everyone? Is it clear to everyone to talk
Yeah.
about? Yeah,
So
perfect,
will it
perfect.
be also included in the code, or like it's by default added?
No, sir, actually, it is included, it is inclusive of their code. They change the parameter during the, like, fine web, when at its backend, right? If I talk about, right, while creating it, right, would be having the similarity score, which is talking about if 75% of the thing is matching. For, I think, for fine web, it is actually 65. Let me see. I think here you will find it as well. I think so. यहाँ पर आपके पास वेब डेटा इन्होंने they have made it nicely. They have a lot of things which they talk about, right? Let me see. Where do we have it? Have it. Yeah, can you see this? Look at this. Here it says applied fast text language classifier to keep only English text with a score of greater than equal to 6.65, meaning 65% of the content should be, what do you say, at least English. You got it, right, sir? And I think you can understand why are they giving that 35% flexibility? Because you might have seen, sir, that ChatGPT is also good at translation tasks as well, right? So that 35% comes from that those website will be containing English to some kind of a language translation that might be contained in those corpuses as well, right? So it gives you are having English content because primarily you want the entire language to behave, or the what do you say, large language model to be aligned towards English, but also at the same time it should go through this process of these things as well. You got it, right, sir? I think more or less it answers your question in the context, right? Perfect. So they set it. You're right about it. To answer the question in one line, yes, they have the code through which they might have set the score as 0.65, and that is what is being reflected here. Let me go back here. Okay, you can see here language score, it says 0.97, right? You can see that if you talk about, right, more it is this is what it talks about, right? Let me go to any random stuff. Can you see 0.87, right? These are all numbers which are greater than what do you say, uh, 65, right? If I talk about, let me randomly go to a third page here, maybe, right, just to show it to you here. Okay, let's go to this. You can see here, right, 0.79, right, 0.97. You can see the numbers, right? These are all having, what you say, similarity scores greater than or equal to 65 as set by them. So the idea here is, suppose I create a corpus, we can also create our own corpuses, right? We don't have to depend on fine web. If you are not interested into using someone else's corpus, right, we can take our own corpuses as well. We can create a crawler, and based on that, right, based on the similarity scores, we feed it through, and then it goes through in with the process of utter refinement. Is it understandable? This explains you how you can create your own corpus, okay, and also have few things in mind so that it is aligned towards what it is supposed to do. Easily understandable by everyone? Yes, no, maybe? Everyone got the context? Perfect, perfect. That's great. Let me close this up, right? Let me also rub this off from here. Yeah. So you can see here, right? We were at this point here. Okay. By the way, Fine Web is a very large, you can see, right? It occupies a lot of, what do you say, disk space, if I talk about, right? They have also introduced a smaller version of it. You can see Fine Web for education purposes and stuff, if I talk about, and it is a very high quality annotated. You saw those, they were annotations, by the way, right? From which website it has been collected, is it in English, what is the similarity score, that is the annotation which we are talking about, right? So Fine Web edu is one of the versions, so you can click on it and go to that and look into it as well. I don't want to talk much about it, but you can see it has relatively lower number of what do you say, tokens, right? You can see 1.3 trillion tokens, compare it to 15 trillion tokens, right? It is like 1/15th of the original content, but these are of high quality, meaning you can achieve relatively good performance even when you use these. Is it understandable? Yes or no? About the context which we are talking about, it is a smaller bacha of that bigger stuff which has been talked about, right? Now, next important thing to talk about, I told you about, I'll introduce you to that website, right? If I talk about, right, there's the Common Crawl. This is the website, right? It is a not for profit. You can see, right? Non-profit, founded in 2007, and these guys are crawling the internet since that year, by the way. And by the way, if you are really interested into looking at into how the data looks like and everything, the data, you can go to the data, right? And click on this overview. By the way, in case you guys are interested, let me go to and share this to all of you here, right? And I think that should be good enough. Yeah. So you can go visit this website, right? That's the company which is doing this hard work for many of the things, right? So you can see choose a crawl, right? You can see that from 2008, these guys have been crawling the internet, right? So you can see they form batches. So they have, I think, roughly around 100 batches of it they have released. I think that's more or less if I talk about the count and stuff, right? I think more or less it would be somewhere available here as well. Yeah, 96 common crawl snapshots, roughly around 100. Okay, if I talk about, let me show you what it looks like, right? You can see that they have been crawling every month. If I talk about every month or every alternate month, if I talk about, you can see that this is for the year 2025, right? And you can see the 30th iteration or stuff. If I talk about, let me click on it, the latest one. If you talk about, look at this here, guys. Okay, it is the total size compressed is 88 terabyte of the data of the internet which they have, what do you say, crawled upon. If I talk about, it is free to download, by the way. You can click on it, and if you want to go ahead and download, please feel free to download it, right? But these are the real sources from where data actually comes from for training these giant models. Okay, be it any bigger model you talk about in the context, right? If I talk about, that's how it works out. Is it understandable? And by the way, look at this particular snapshot, right? This particular archive contains about roughly around 2.5 billion pages, right? So 2.5 lakh sorry 2.5 billion के आसपास इसमें pages, the snapshots that have been collected. Is it understandable? Yes or no?
Yes.
Everyone understood the context, right? Perfect, perfect. So, all right, so the idea is you can go to the Common Crawl website, right? This is the website where you can find the archives, right? Feel free to download it. I think none of us have that, what do you say, TBs of space, if I talk about, right? That's why these have been specifically created for large language models. But suppose you guys suppose some interested people start off their own company and stuff, right? They have like the flexibility of downloading it because these get enough of space and to work around with the context there, right? So that's the whole idea here. Okay, now let me come back to this, right? So you can see that these are the high quality data which are available and stuff, right? You can see the context there, right? You can see it says you either crawl it yourself or companies such as OpenAI or Anthropic, among others, do. ठीक है, ये लोग they use it, okay? They use it, and that's the whole point of it, okay? So that's the first stepping stone of how the things work out, okay? Now, moving forward, right? You can see the recipe here, how they do it, right? You have few of the things, right? Obviously, it talks about the URLs, right? By the way, when I say URL filtering, it's very important to talk about one more important thing. I think there is the set of exclusions. You can see applied URLs, filters using block list, right? So there are some specific exclusions to this, right? If I talk about, right, I am not sure if it comes up here. Not sure. So I would have actually shown you the exclusions. So this is the list of exclusions. By the way, it doesn't load up for me. I think if it loads for someone else, please let me know. I think guys, someone, right? If I talk about, right, see if you can click on this website, right? I used this website earlier, right? It is currently down, I believe, in the context there, right? But as of now, it's not working, at least not for me. Maybe if it is an internet kind of an issue
Not
from my
working.
end,
Same
is it
issue,
working?
Saumya. No, no,
Not
same.
working
I think
for
server is down.
yeah, it would be server downtime maybe, sir. So actually, I would have probably shown it to you all, right? It contains those things like, for example, adult-based content, hacking-based content, right? So all those genres which should not be there during the time during the training, right? That is by itself, I mean, omitted from consideration. Okay, so that's the whole point of it, right? And if you are taking this refined data, right, companies like GPT and stuff, right, if they are using these refined data, then you can't expect it to answer those things which are what you say coming up. I mean, if I talk about in the context of which are not in line to be what should be questioned, right? If I talk about, they do a lot of those things in the context, right? That's the whole point of it. The idea is you want to do, I mean, filter out the context, right? You can see various level of filters, right? You can see language, Glofer. You have mini hash, C4. There are custom filters. You put your own filters, and at the end, you also want, right? You might have seen, right, that they give a disclaimer. What is PII, by the way, guys? Anybody? Anyone? What is what is PII? Anyone? That is basically nothing but personal information. I think personal identification information, meaning those infos which identify a particular person. Because obviously, there might be some content, right, on the internet, right, which might be talking about those, right. So those things also have to be removed out in the context there, right. So I hope you can understand what it talks about and how it works around with the context there, right? So lot of filters, right? There are, you can think of it as layers of filter, and then super fine grain or a super fine water comes out of it, right? And then you take that raw water, right? So what I mean to say is, right, this is not completely raw, right? You make it into a corpus at the end of the day. Now after such so many refinement process, right, you may like it is now ready to be rest, or what do you say, ingredients for further processing. Is it understandable by all of us? Let me keep this up here. Everyone got the understanding? Yes, no, maybe. Is it clear for all of us? Right? All of us got the idea? Perfect,
Yes,
perfect.
Soumya. Yes,
Yeah,
yes.
perfect. Perfect. So that's the whole point of it. You can see the context here. You have deduplication, toxicity, and spam. These kind of all the websites are formatted or basic, I mean, removed and stuff, right? They go through that process of stuff. I mean, that process, right? So you have this raw web crawl. You can see you talk about deduplication, meaning if there are duplicate entries, then make it unique, right? If I talk about, right? And then you have the filter toxicity or the spam, right? If I talk about, then the formatted data, right? And finally, if you talk about in the context, you have the clean training data set ready for the stuff. Okay. Now let's move forward. Now that you have the data, right? Everything is cool now, right? If I talk about, right, we have the data, we have seen everything in the context here, right? Let me cross these over, right? Yeah, it's side medicated. Yeah, anyways. Now, the next thing is, if I talk about, right, you can see breaking the language into Lego bricks, right? Or if I talk about, right, the ones that are particularly understandable, right, for the machine to talk about, right? So the very next step is, if I talk about, right, tokenization, right? The step number 2 in the context, right? So you can see that, right? I mean, if I talk about, right, when the model tries to learn, right, from the language, right, it is very important that it is converted to some kind of a token based sequence, right? If I talk about, right, now, one of the most very, what do you say, widely used algorithms used in this, right, if I talk about, is called as byte pair encoding, right? What do we understand by this word, by the way? Anybody would like to tell me? What do we understand by this word?
It thing which will consider like 8 bit, it is called as a byte. Maybe
Right,
such
sir.
kind of information or such kind of like this, what you can say, data frame which you used to take as a pair, if I'm not
Okay,
wrong.
perfect, sir. I'm very happy that you tried. Nice, sir. That's actually I mean close enough, right? If I talk about right now, in the context here. Thanks so much, sir. Anybody else would like to give idea? Thanks, Raja, sir. Awesomely said. Anyone else?
It's a tokenization algorithm itself.
I think I can see if it is
Uh-huh.
a binary number, it will tokenize the meaningful pattern from it.
Okay, sir.
Like
Okay,
something
meaningful.
like into ID numbers, it will be
Uh-huh.
generated.
Okay. Okay, nice, Aman sir, and Aditya sir also said that for the purpose of the tokenization and stuff. Yeah,
Others, you
Raja
tried
sir.
something, but others,
Sorry,
your voice
Adarsh.
is
I'm
very
sorry.
low. Yeah,
Yeah.
very low, others. I think yesterday
Uh,
also same thing happened.
Is it audible, sir? Now is it audible?
sir, काफी low है.
Voice is audible, but very low sound. Like volume is very less.
Laptop, some issue is there.
Okay, sir. No worries, but sir, we can hear you. थोड़ा सा. That's okay, sir. अगर होगा तो sir, if you can put some earphone or something in those lines, that would be great.
I am in earphones itself. Laptop में कुछ
Oh,
नहीं हो
okay.
रहा है.
अच्छा. So that's bad, sir. चलो sir, कोई नहीं sir. Yeah. So what I got from your what you said, sir, you said about the process of tokenization, right? If I mean, you talk about in terms of creating tokens, right? If I talk about and perfectly, Aman sir also said that, and all three of you iterated it perfectly, right? Let me talk about it a little more. If I talk about in the context, right? You know, the context is, what is the meaning of the word pair, by the way, everyone?
The sum of two numbers
हाँ,
taken.
दो चीज को पेयर बोला जाता है, राइट सर? सो आई से दिस इज अ पेयर ऑफ two numbers, right? Everyone agrees, right? So this is pair of two numbers, right?
Right.
Similarly, yeah, I say one and maybe shoe. These are pair of two words, if I talk about, right? Instead of numbers, I can say words, right? Right? So I think you can understand, basically each of the character, right? The way it works is each of the character. When I say character, when I write the word one, right? There are three characters, okay? Each of these characters are singular bytes. If I talk about in the context, they are represented using eight number or eight bits. If I talk about, is it understandable to everyone, right? Is it clear to all of us? Are we able to
Yes.
understand? Perfect. Now what you do is bytes. So basically you are calling these singletons as bytes. Okay, for now the idea is you're calling these singletons as bytes. Okay, so what you do is you try to make pairs of it, right? So if I talk about in the context, right? So ON is one pair, right? If I talk about NE is one pair. So, I told you earlier, right? There are 15. So let's go back to our fine web data set, right? We have fine web. There you saw there were 15 trillion tokens, right? Which it has been trained on. Let's say for our convenience, let's not call it as tokens. Let's call it as words, okay, for our convenience. Okay, there are 15 trillion words, okay, but that is not the case, right? If I talk about, right, so it has been, let's say it is 15 trillion words, right? So that means now you take those 15 trillion words, right? What you do is, suppose in the context, right, if you talk about, you write them one by one. Let's say the one of the word is hello, right? HELLO, maybe swim. Okay, maybe there is something called as swimming, right? Maybe some word. I'm writing random words. I told you, right? This is website, right? So the internet is filled with different words, right? If I talk about, right? Maybe quantum, right? Maybe let's say calculus, right? Okay, I'm just making these stuffs up, right? Now what you do is each of these bytes, right? You take each of the characters, right? And you make pairs of them, right? So HE, there is EL, right? LL and LO for the first one, right? Same way, can you do it for the, can you tell me for the second one? What would it be, guys? You make pairs. What do you do next?
SW,
Yeah, exactly.
WI,
Perfect, sir. And
IM,
IN. Excellent. IN, N,
IM,
MM.
M.
Yeah, yeah. So I only forget what I've written. Greatly said, sir. Exactly. Right. So same way for this, exactly, right? WI.
It's like n-gram. I think bigram like that.
Sir, I
Kind
mean,
of.
yeah, kind of, right? But you make pairs here. That is a little bit different. But here, if you talk about, you make pairs, right? Now, why am I making pairs? Let's see, sir. Okay. So I said then MI, then IN and NG. I've written for that, right? If I talk about, right? Now, suppose these are the only three words I'm taking. ज़्यादा बड़ा हो जाएगा और दो ले लूं तो, right? So let's talk about it. Now, individually, I take the complete corpus. Suppose there is nothing like this, okay? So I say that hello, right? There are three words only, right? Now I say what is the frequency, okay? So HE, how many times does it exist in the entire corpus? I think it exists only once, right? If you see it, right? Nowhere else it is existing, right? Everyone agrees, right? Yes or no? Everyone? Yes, no, maybe.
Yes.
Perfect. Same goes for EL, right? Once. LL also once. LO also once, right? I don't think out of all these three words, it exists multiple times, right? Now, I go to SW. SW is existing how many times, by the way? In this entire.
2.
Yeah, exactly. You're right. So this is for SW here, the second word. For the third word, there is another SW here, pair, right? If I talk about. Agreed. Do you agree with that, Aman sir? You understood,
Yes,
right?
yes.
Yeah. So there will be two, right? If I talk about, right? Same way, WI also exists two times, right? I am, suppose, let's say I say swin, okay? Or if there is some word IN, okay? There is a reason why I'm doing that because you can see IN will be existing 1, 2, and 3 times, right? In this entire corpus. Let's say I'm just taking IN, not IM, right? Just to show you, okay? So this is how it works out. Do you get it? So you do it uniquely for all the words which are part of your entire vocabulary set. Is it understandable? Yes or no? समझ में आ रहा सभी को? Perfect, 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 perfect. So that's, yeah. So you have something to say? Aman
Like,
sir?
did you
Yeah.
make any changes here? Like, IN is changed in first word, right?
Yeah. Sir,
Yeah,
I deliberately changed it to IN. Okay, because I wanted, you saw SW exist two times, right? I just wanted to show you if it was IN, it would have existed three times, right? That's all I wanted to show you. That's why I changed it. Else, if it were IM, it would have only existed twice, right? You agree, right, sir? You understood,
yeah,
right?
yeah,
I
yeah.
just wanted to show
Yeah.
you frequency. That's why I just
Mhm.
changed it on my
Okay,
whim
okay,
at
okay.
this point. You got it. Just to give you. So you see that IN is existing thrice, right? If I talk about. You just don't make pairs like this. You move to the next. So you do this iteration, okay? So now you have 15 trillion words, okay? By the way, there are no 15 trillion words in the English dictionary. So it is, I think everyone would, what do you say? It is safe to say that why not take a set of these 15 trillion, right? Everyone agrees? Why am I saying set of these 15 trillion? Is it understandable why I'm saying that? Yes, no, maybe. So that you don't have to repeat the process again and again if the words come again and again, right? You want to have pairs. Yeah, Adarsh sir, you are getting like you unmuted. You wanted to say something? Yeah. Okay, perfect. Yeah. So I'm creating a set of 15 trillion. Now, I think more or less it gives, I don't know how many words are there in the English language, right? So total words in language, whatever. I think you can understand. It shows me around what do you say, more than a million words, right? So out of that trillion, right? You reduce the entire corpus to just over, like, you divided it by 10 to the power of 6, right? If I talk about, right, and that's a huge jump, right? So I think more or less you have a set of it, right? Unique words, right? And then you move forward doing this step, right? You saw, right? So you take those 10 million words, right? And you make pairs of it. Is it understandable? Yes or no to everyone? By the way, सबको समझ में आ
Yes,
रहा
sir.
है मैं क्या बोल रहा हूँ?
Yes,
Perfect,
yes,
Yes.
yes, sir. Very clear.
perfect. Awesome, awesome. So we take a set of it and then we make pairs of it, right? Perfectly said by all of us, right? Now, when you do the pairs, right, you don't stop there, by the way, okay? You make pairs. You made a pair of SW and you mentioned it as what do you say? Now what you do after you go with one iteration, you completed one iteration top to down, okay? What you do is again repeat the process. When I say again repeat the process, what do you do next? You say SW, okay, becomes one token, okay? Earlier, it was two separate tokens. S and W were separate. You made pair of it, okay? Now you go to the next, and what you do is you take this entire set, SW, make it as one token, okay? And whatever is coming next, you do this SW concatenated with I, right? You make it as a new token. This again becomes a pair. Do you get it? Are we understanding? Yes or no? Yes,
Yes,
no,
sir.
maybe.
Yes,
Yeah,
sir. Yes.
exactly. So the idea here is, right, you keep on repeating this process, okay? Okay, the idea is very fairly simple here. You keep on repeating this process until you talk about, right? Again, then you again take SWI, right? Maybe as one of the token, and M and see how many words such are there. So for swimming, right, you will, for the word swim, you will have one, and again for the word swimming you will have another one, so it will again be two, right? If I talk about, right, so you make pairs like this, right, and you do it for all the words. So it is a very computational intensive process because you are making pairs and there are so many number of words to talk about. Is it understandable by everyone? Yes, no, maybe सबको समझ में आ रहा है. By the way, last time when we discussed about, I told you that GPT-3 has been roughly it has around 50K tokens, right? But the number of words are 10 million, right? If there are a lot of words, right? But the number of tokens are very less if I talk about in the context, right? So I think you can understand these tokens, how are they formed? These are formed because of these associations. Do you get it? You make these by using these associations. Okay. So you use the idea of byte-pair encoding, right? And then you encode it, right? You call, I think you can understand this SW may be called as token number 80. Okay. Now, when you paired SWI, maybe this might be called as token number, some random number 1015, right? If I talk about, right? So this is how the things club out together. Is it clear for all of us? सबको समझ में आया मैं जो बोल रहा हूँ? So you start by each and every character, you split the characters, right? Then you club them together, right? And then you do this, right? You might be wondering, right? Can anybody tell me ये सब हम कर क्यों रहे हैं? I mean, what is the use of it? What is the fun of doing this? I could have taken each and every single word and I mean, as a token, right? And then I have what do you say? I don't have to worry about these things, right? तो ये करने का क्या मतलब है? Anybody like to think? Just think logically. I mean, just wanted whatever comes to your mind. That would be great.
So can I? May I?
Yeah, please, sir. No worries.
Yeah. So basically, by doing, this is very, a very strategic play when you want to recognize the tokens and in the lowest byte, how you basically get the proper concept. So that is actually the main motive for using this type
Exactly.
actually.
Exactly. Brilliantly said. Context representation, just like how Sir said, right? Context, as well as how you can easily make buckets of the content, break it into some pieces, right? And then look into it. Okay. So that is the whole idea behind what we are talking about here, right? Brilliantly said by Aditya sir here. Okay. So I am rubbing this off. Anyone having any questions so far? Please let me know. किसी को कोई questions अभी तक? Shall we move forward? Yes, no, maybe? Everyone, सब सो गए क्या? Okay. All
So,
I
right.
think Aman sir was having, I guess,
Yeah.
something. He just
हाँ,
having.
अमन
नहीं सर,
sir?
नहीं सर, मैं बोल रहा था कि चलिए आगे.
Okay,
Okay,
perfect,
okay, move on,
perfect,
move on.
perfect, perfect.
Let's
Nice,
move
nice.
on.
Awesome. Awesome, sir. So you see that first thing which we just discussed about byte pair encoding. I think you can understand simply pair means making a pair of two, right? You start from very basic stuff. Start with small, what do you say? Each single byte, that is a character. Make a pair of it, then club those two. Again, do the same thing. Make pair of it. Club those. Make pair of it. So this is an iterative process, right? So I think you can understand. If I were to write a program for this, it will be easily iteratable. You will be able to think about it, how the byte pair encoding works like, right? In the packet, right? Brilliant. Now, next, moving forward, right? One of the key contexts, if I talk about GPT-4, uses CL, or in fact stands for core language. CL stands for core language 100K underscore base tokenizer. That means 100K means 100 triple zero, right? Which is roughly equal to 102. What do you say? What is this, by the way? 1,277 tokens, to be specific. Is it understandable to everyone, right? So this is abbreviated as this, right? So the base model, the base variant is used to that, right? So you can, this is a very fun site, by the way, right? Called as Tick Tokenizer. Let me share this site to you, okay? This will show you how different tokenizers exist, okay? Let me quickly share it with all of you. Okay. Please feel free to navigate it, right? If I talk about now within this site, you can see Tick Tokenizer, right? Let me select here one of the there are many of it, right? Different models use different tokenizers, okay? But the most popular among them are these, right? If I talk about, right? We discussed about what do you say? uh, GPT-3 earlier, right? I told you GPT-3 contains over little more than that of 50,000 tokens, right? So that is in fact, to be precise, it is actually R50K base token is what is GPT-3 using. Do you get it? Understood, right? Yes, no, maybe to everyone.
yes, sir.
Everyone got it? Perfect.
Yes,
Now
yes.
let me quickly go to CL100K base token. Okay. Now, whatever I write here, right, will give me how it looks like in the form of tokens for GPT. Okay. In fact, GPT-4, right? So let me say, I say here, right? Hello, everyone. Okay. Guys, please select CL100K underscore base if you are trying it. Okay. Welcome to Transformers session by Saomya. Okay, I have just talked about that, right? You can see I have written my message here, right? Now that message, right? You can see the highlights on the right hand side, right? You can see how the token distribution is happening, right? You can see hello is one of the tokens, right? And space everyone is one of the tokens, right? I have this as that. I mean, we have many different tokens if I talk about in the context here, right? Welcome to Transformer session, right? If I talk about, right, you can see how the language is getting divided here, right? If I talk about, right? So I think you can understand more or less many of even I think earlier in our earlier sessions, Aditya sir and I think others also. At that time, he meant like I had asked the question about. Obviously, Saomya is not recognizable by GPT-4 if I talk about, but how does it what do you say, understand that I'm talking about this name, right? You can see this, right? The word Saumya has been divided into three, what do you say, sub tokens, if I talk about, right? You can see that, right? Saumya, S-A-O, O-M-Y, and there is A, right? If you talk about, and if I just navigate there, it has a nice GUI. You can see those numbers as well, okay? So I think more or less you can understand the context here, right? Now, there is one important question which I want to ask you, just a logical question. You can see everyone, right? Let me just elongate this further, okay? I want you to pay attention to
Uh,
this part. Yeah, tell me,
Sorry to
sir.
interrupt you, sir.
Yeah, sir.
Sir, could you
Go
please
ahead.
just repeat this thing once again? I just got disconnected
Okay. No
because of
worries, sir.
internet. Yeah,
No worries,
thank you,
sir.
sir.
Sure. No problem. So, yeah. So, sir, do you want me to repeat from the website itself, from the beginning, or
Uh,
where, sir?
no, just how this is working. Like, what is the
Yeah,
purpose of?
exactly. So, sir, I just want to show you. By the way, did you select the right side here? You have selected CL100K base, right, sir?
Yes, sir.
The
Yes.
core language 100K tokens, right? If I talk about, brilliant. Now, I've written a message here on the left-hand side. Right, in the transformer, right, when you feed in the transformer, right, if I go back to this model here, right, I told you, right, that when you share the, when the sequences are fed, right, they are broken down into tokens, right? Tick tokenizer tells you how those things are broken, okay? For specifically for GPT-4 model, okay? We are discussing in alignment with GPT-4 model, okay? Because CL100K base is a tokenizer which has been used for GPT-4 during the time of training in GPT-4, okay? Similarly, I told you that there is this one as well, right? CL का कहाँ गया दूसरा वाला यार ये I told you, right? There's the R50K base token, right? If I talk about, right, which has been used for GPT-3, for training GPT-3, if I talk about, okay? So that contains 50K means 50,000, roughly 50,000 tokens, right? So how many unique tokens are there here in this? So you see this number 9906, right? It is one among the 1 lakh tokens. You see the number 5127, that is one among the 1 lakh tokens, right? If I talk about, you see the number 0, that is one among the 1 lakh tokens, right? You see the numbers 20,776, right? That is one among the 1 lakh tokens, right? Because I hope that's particularly understandable. Is it understandable to this point, Aman sir?
Yeah,
Did you
yeah.
get it?
Till this point, it
Perfect.
is clear.
Perfect. Now, next, moving forward, actually, I wanted to pose a question to all of you. Okay. Now that you see this, right, there is something interesting happening here, right? Look at this message, right? You see, what is the interesting pattern you can see here? Can anybody tell me? One thing which we saw that the word Saumya has been divided into three tokens. That's fine enough. Is there any other interesting pattern which you see here?
Can you just scroll down the numbers once?
Yeah. Okay, sir. Okay. Yeah, sure. We have this and we have the numbers here. Yeah. Okay. Anyone? What interesting thing do you see here? I mean, just a thought. I mean, anything which is alarming to see here, along with you saw one of the alarming fact that my name has been broken down, and we were able to explain why that happened. Anything else which you see here
I
in that
think
same?
I think it is like word tokenization,
Okay, sir. Yeah, I mean, there is
except the
words.
Saumya.
Okay. You can see word
Even
token.
even
Okay,
exclamatory
nice.
symbol has been tokenized. right?
Exactly, sir. Brilliantly said. Yes, in fact, the number 0 represents the exclamation sign. Brilliantly said, sir. Yes, exactly. Uh, awesome. One thing is word getting tokenized. The second one is you can see the exclamation signs as well. Obviously, those are characters, right? They have to be tokenized as well. Perfect. Anything else you see? Something
Space has
else?
not been given any
Three
importance.
words. Sorry.
Exactly. So there is one big important thing. Sir said about word are getting tokenized, but you can see that even spaces are getting part of the word itself, right? There is no separate token for space, right? You see that there is no special token for, or in fact, special symbol, special number reserved for the space. Does that mean, I mean, space is not given any value? What do you think? Does that mean space is not a character to talk about? What do you think?
No, obviously, spaces are also included.
Yeah,
In the
exactly. Hmm.
I guess in the end of every character, no? It is like O and E. In between O and E, the information.
Okay, okay.
Maybe
Because
like
sir,
the way are different, but
uh,
like spaces are there.
awesome,
And
sir.
there
I
is
mean,
a
there are. Uh,
after every word, for every word, there is a number which is given. After that, there is a comma, right? So that comma,
okay. You're saying that the comma is representing a space?
no, it's
Is
not
that what?
representing a space. It gives that
Uh-huh.
that
No,
there
no.
is a.
Oh,
It's not representing
oh,
space, but it's.
I think
I
it is
think
taking all the words
I
In
as
did a
generally
token.
word
blunder, guys.
tokenization, the word will be tokenized with the help of the white space.
Uh-huh.
So
Sir,
I
I'm
think
sorry, guys. Everyone, this is former session. But okay, yeah. Sorry, sirs. Yeah. Coming back. Yeah. You were saying, sir. Word tokenize. Earlier, sir repeated it. Adarsh, you were saying something earlier? That
I was saying that every word is split, and that split can be understood after like space can be understood that manner is
uh-huh.
what I feel. So space is considered.
Okay. Okay. So actually, frankly speaking, sir, if I were to tell, can you tell me, guys, what is that character in the entire of the English language, which is the most used character? The most used character in the entire English language. Which one is it?
white space.
You no,
two.
like
Like
in English
exact.
alphabet, now out of 26.
हाँ सर मैंने भी अपना जो क्वेश्चन है ना सर बड़ा घटिया तरीके से पूछा आई मीन व्हाट या एक्चुअली आई वांटेड टू गेट टू द पॉइंट गेट टू द आंसर ऑफ व्हाट राजा सर सेड that actually it is space but it is not a character. You're right. I mean it is not a alphabet. You're right about it. So I
It's
just
a
wanted to
special
probably
character.
frame it like this. Yeah, exactly. Which is that character in a particular English language which is used. Yeah, I can say character because I'm not saying the word alphabet. So, what is that character used in the entire English framework of large sentences and everything, right? Which is most commonly used. I should have said it right that way. So, for that,
I think
everyone agrees? Huh. Yeah, tell me, sir.
yeah,
Yes.
vowels are used most commonly.
Sir,
No.
sir,
Character.
no, sir.
Single character. Vowels are
Character.
five,
Yeah,
na.
character. No, yeah, alphabets. Vowels are alphabets. I'm not talking about alphabets. Yeah. So what is it?
Even if we
Everyone?
talk about that, that space is the most
Yeah,
used.
exactly. That is what I wanted you all to arrive at, right? So the space character is the most widely used. You see a big passage, space will always be there, right? After every word, you encounter a space. So let's think about it logically, guys, right? If you see space as a character, okay, every now and then it is appearing, okay, then it is very troublesome to talk about. Why? For a very simple reason that the number of tokens will all obviously, because there is how many? 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 spaces. Whatever I have written here contains 8 spaces. That means if it were treated as a token, right, it would have been 13 plus 8. That is, what is it? 21, right? Everyone agrees to that, right? So basically, useless piece of information, adding no value to it, right? Containing being contained in the middle. Do you get it, guys? Is it understandable? Yes, no, maybe.
Yes, yes,
Yes.
Yeah,
So,
yeah.
yeah, instead, yeah. So, a logical choice would have been, right? So, what they did is they imagined the entire thing in the form of like, let's split it up, right? But not using the delimiter as space. Rather than that, just split it into words, okay? And the space should be part of it, right? And that's how you basically, I think you can understand, even space as a character was used for byte pair encoding. So space followed by E, space followed by T, space followed by I. Do you get it? And then you again make it like space I, then followed by S, right? Do you get it? For byte pair encoding. Is it understandable? I mean, how they thought they could have thought about it, right? We are trying to mimic their thinking process as to why they did not create it. Because obviously, if you go about doing this, right, you are going to keep on generating unnecessary tokens, right? Which are like adding no further value to it, right? Because they will be repetitive. And I think you can understand while training, right? The trans, because you know, right, how overfitting is a big problem, right? If I talk about, right, it overly sees that space every time, right? And it will be inclining towards giving you spaces, even though you don't want to have them. Do you get it, guys? Is it understandable? Yes, no, maybe.
Yes, sir.
Is say,
Yes.
yeah,
yes, Soumya.
perfect. Perfect, sir. Perfect. Now, by the way, you if some of us are wondering, is I mean that means is space will not be having any token. Let's see that. You can see for a space character, there is a token called 220, which is reserved for space. But during the time of training, right, they are not taken as individual tokens. Instead, they are given. So जहां पर हमको लगेगा कि मतलब we have to use spaces, right, in the context of the tokens, right, then go forward and use that in the context, right? So that's how it works around in the conceptual understanding. You can see there is a token reserved for 200, and I mean token number 220 reserved for the space, right? But when you talk about words, it is still there, right? If I talk about easily able to understand, yes, no, maybe, guys, समझ में आ रहा है सबको,
Yeah, yeah.
right?
Yes,
Yeah,
yes.
awesome, awesome, awesome.
So like
Now,
actually,
yeah, tell
yeah,
me.
in this actually when we are talking about this BP, so what we have like this context defining boundary that
Huh,
basically for every character. Even this
exactly.
spaces also like works like a clue that there
True.
is some type of a specific word would be there. So
Exactly,
that is basically
exactly,
required in it.
exactly. Because thanks to this space, you are able to have that clue to get the complete word, just like how Sir has mentioned. Very nicely said. Yes, exactly. It adds a lot of clue to what you're talking about, right? Everyone else, brilliant. Thanks, Aditya sir. You have anything else to add, sir? Aditya sir?
No, sir, nothing, nothing.
Okay, perfect,
Yeah,
perfect, perfectly
if
said.
I just if I just wanted to add also,
Yeah, yeah.
I don't remember that. I guess you had asked a question maybe that why
Uh-huh.
this yellow hello everyone and why exactly this Saomya
Uh,
is in a different colors. So I wasn't able to answer because some other
that's
things.
that's fine. Yeah, exactly. Now it
It
feels
was only
like
just yeah like
uh,
there is some other context also as Soma is basically a noun and does not it does not include in the vocab. So that is
exactly. It is
also
not
one of
part
the
of it.
reason here.
Uh,
So
uh,
it is trying to
exactly.
identify that after that the green color space and essay.
Yeah,
So it is having some
exactly.
different context and Om is actually a tied sorry, the token in the vocab. It already has.
OMY,
So that's why,
exactly.
yeah.
OMY is a token in vocab. You're right about
It happens, I guess, with the nouns
Exactly.
and not adjective, I guess, only for nouns only, I guess. Right?
Yeah, I mean, sir, yeah, mostly nouns, because, sir, nouns are the things which are not part of dictionary, right, sir? So if you talk about, right, so more or less that is how it works out. But maybe for some famous personality, I think Albert Einstein. Let's see, he's famous. I'm not famous, so let's say, yeah. Can you see this?
Yeah.
Ah. So the word
We
Albert has been given.
we believe that one day your name also comes in this color.
Yes, sir.
अरे
Yes, sir.
सर क्या बात कर रहे सर डोंट से दैट सर मुझे झाड़ में मत चढ़ाइए सर That's
So
a good one.
could you give it a try
हाँ
with Virat Kohli once?
हाँ
Yeah,
definitely sir why
yeah.
not Virat look at this he's not so famous sir you can see the
Yeah.
bifurcation so Kohli okay yeah so it is breaking down so the giant
Might use the
minds
latest one. Might be the latest one. It'll work. Which one? Are you
which one
using,
sir
the tokens? Which model are you using right now?
Sir, I'm taking CL100. So this is relatively an older one, which has been used for training GPT-4. So GPT-4 released when, sir? When was it? I think almost a year back, I believe. Everyone agrees, right, sir? I think GPT-4 released that time only. I'm not sure.
Yes, sir.
I think Virat
हाँ
Kohli
तो
should have been there.
ये आदर्श को कुआं से उठा
नहीं
दो कोई
Just
कहीं
just
वेल
check.
से माइक से दूर बैठ के बात कर रहे हो वो
Raja sir will be there for sure. Raja, you tell.
Raja. Yeah. Oh, sir, Raja, sir. R and Aja. It is.
आजा आजा
Aja. Raja, sir. So I think more or less, sir, it's a fun game to play around. Yeah, actually, you're right. So many of the things which are pretty much part of it, sir. You know the reason why it is happening like that? It is because let me give you a very shorthand description. कि Albert Einstein क्यों है और why Virat Kohli is not there. It is a very simple, fairly simple reason, sir. See, these all tokens have been created from internet documents. Everyone agrees, right? So some
Yes.
bigger internet corpus you have, right? So it is high chance that while going through this training process, while bifurcating, it might have come across Albert and Einstein many number of times because it is a very कॉमन नेम यू कोट आप कहीं पर भी जाओगे तो वो बोलते हैं ना लाइक एल्बर्ट आइंस्टाइन मे बी इवन शेरलॉक होम्स आई थिंक आई डोंट नो yeah is this guy also one yeah look at this so this guy is about Sherlock Holmes right the greatest I mean fictional detective which we had right if I talk about right by I think Conan Doyle will it be Conan Doyle I don't know yeah. So the Sir author Conan Doyle, who is the writer of Sherlock Holmes, his name is also there, if I talk about, right? So more or less, you understand, right? What happens in the context here, right? So these are the most frequent words while during the encountering the entire corpus, right? You saw, right? You saw me going through that common crawler, right? It is created with 65 trillion, terabytes of data, right? So many a times it might have come across Albert Einstein, many a times it might have come across Sherlock Holmes and stuff, right? If I talk about, and that's how it got trained on. Is it understandable, right? So because it saw so many frequent words, right? That also gives a, what you say, weightage to the overall token size, if I talk about.
In
समझ
short,
में आ
like
गया सब
tokenization is more vocabulary driven and it's not intelligence driven.
Yeah,
It's not based
exactly.
on intelligence, and there is so
Exactly,
much
sir.
bias
It is.
with training.
Yes.
They're trained
Yes.
with a lot of
Yes.
English words.
Yeah, exactly, sir. The idea is they have been trained on so much of English corpus, right? And then there is that byte-pair encoding repeating one after the other, right? So it sees very frequently these terms and stuff, right? And that is why it makes, what you say, use of it in the overall process of tokenizing it, right? So the only difference is this is containing 100,000 stuff, right? Now, my question to you is, guys, a simple question to everyone. What if everyone looked at this, right? Uh, what will happen? I have written hello here, okay, right? And I write hello in lowercase. Do you think the token for this capital hello and small hello would be the same? Yes, no. What do you feel about it?
Same, I think so.
Same, right? Because it means the same, right? Let's see, sir.
No.
You see the number here. Someone good at memorizing, please memorize it. It is 9906. I think I can also memorize. Can you see this? These are few things which I wanted to share up. Okay. So what can you tell me what do you think this tells us about the training, guys? What do you think this tells us about the training? What do you think?
Case
That
sensitive.
you see the word hello, capital hello differently and small hello differently. What does this tell us about the training? What could have happened during the time of training?
Capital hello comes very rarely, I guess. Whenever we are doing by-pair encoding, so in
Okay,
that
sir.
case, most of the time we'll be getting a small h in between
No,
words.
sir.
Ah,
Sir, I think you're getting confused that you saw the smaller number 9906 and you are seeing 15K here, right? Sir, this has nothing
yeah.
to do. I mean, this has nothing to do with the representation. Sir, these are random numbers. It's like male equals to 1, female equals to 2. Do you get it, sir? It has nothing to do with
Okay.
how many times it has seen. You got it, right, sir? It is just a token ID. It is a ID representation. Like, for example, sir, Aadhaar ID, right? My Aadhaar 12-digit Aadhaar ID is very different from yours, right? But that doesn't mean that whatever that number is, I existed after so and so. If I talk about, or that many number of people existed before me or something in those lines, right? So it is just a ID which you are giving. You got it, right, sir? It has nothing
Okay,
to
sir.
do with the frequency. So what I meant to ask you is, but I'm happy that you tried. Now, these small doubts actually clarify the things afterwards. Very nicely iterated. Yeah. My question was, what does this tell you? I mean, capital hello and small hello is both different, right? What does this tell you during the time of training? What had they done in that case? What do you think? क्या लगता है आप लोगों को?
So basically, giving a different IDs, it means like for hello, when you gave a capital HELLO,
Okay, sir. Uh-huh.
it's understanding a tone or emphasizing that it's the start of a sentence, right? So
Sir, again, sir, you remember you just now a little while ago you said that these are not intelligent. They are
they're
not
not
made to be
intelligent, but
intelligent.
yeah.
Yeah.
But
Uh,
why are they getting different tokens? Is because
huh.
the training time also. Imagine you would have given all capital HELLO.
Okay,
you would
let's
have
do that.
you would have got at least 3 tokens, I guess. Yeah,
Yeah,
okay, 2 tokens.
yeah, exactly.
So
Two
it
tokens,
got divided
exactly.
there. So it got divided.
Exactly. Yeah.
So for every other, this one there is based on how much what it has learned in the pre-training. That's how the division is happening. So
exactly.
this word HELLO is not there in the corpus a lot. No one writes like this, giving a lot of all the letters in capital wise, right?
Brilliantly said, sir. Exactly. This shows a lot of pattern. Very nicely iterated, sir. Very nicely said. Not everyone got the answer which others sir said here, right? That more frequently no one writes in capitals. I mean, it might have encountered few of the words, right? But that is relatively less important. No one writes hello in this manner, right? But maybe someone, because so many of the people in the internet, right, they tend to write it in a more proper notation, right? So the idea here is, right, you should understand one thing during the time of training. One thing which other sir said, right, along with that there is one key important thing which I should say is, you do a normalization step. You remember, right? During the time of NLP, applying NLP, you put everything into lowercase or uppercase or whatever, right? Especially you take it as lowercase and stuff, right? These guys, I mean, they did not do it in the context. You do not first, I mean, they did not convert it into lowercase. for a very simple reason. One of the case is, you should understand one thing. They are taking 50 terabytes of data. Okay. Now, first you have, if you want to normalize it, you first have to do dash dot lower, and then it is additionally going to create a 50 terabyte of data. And who, I mean, that's a, like, people don't want to, I mean, that's again going to consume a lot of memory, right? If I talk about, in practice you can do it. Okay, I'm not denying, right? In practice you can actually do it, but in if you talk about the practical feasibility, no one, I mean, taking that giant corpus and then training it, right? I mean, the more trivial things are how you look into the context there, right? Rather than talking about in the aspect which we are talking about here, right? So that's why they kept the entire corpus as it is. They did not process it. What I mean to say is, it was not processed like dash dot lower, and then you make pairs of it. Is it understandable to everyone, right? So they figure, I mean, already you are taking a giant corpus, and then if you talk about in these manners, it's going to be a huge load on the entire thing to talk about. सबको समझ में आ गया? Yes, no, maybe? Everyone?
Yes, Saomya. Yes.
Perfect. Perfectly. Perfect, sir. Now, same way, I think you can understand if I write HELLO. I think you can understand. This comes up as a different one again, right? I think more or less you can now understand things work out in a different fashion, because you have to put a lot of effort in getting to where you are talking about, right? So I hope that's particularly understandable. Okay. So my original session, original thing was, hello everyone, this is a transformer session by Saomya, right? So I think everyone now understands, right, that how these tokens inherently work, right? Through the mechanism of byte-pair encoding, and plus you go through that giant. So agar mujhe banana hota, if I were to create a corpus, right, then probably what I'll go ahead and do is, maybe if I take a smaller corpus, right, I would have enough bandwidth to maybe convert it into lowercase, right, and then do this, right? So who knows, I would have probably just taken a fraction of the number of tokens which are currently part of it. You got it, right? I hope that makes sense to everyone, and you would be able to appreciate what we are talking about here. Yes, no, maybe. By the way, everyone got the concept here. Perfect, perfect, perfect. Now I have this, right? Let me come back to my presentation here. Okay. So you see, right? We just saw that tick tokenizer. Okay. And now you can safely talk about, right, token count examples. If I talk about, if there are roughly around 5,000 characters, they can be maybe roughly around 1,300 GPT-4 tokens. It's, you see, right, you are simultaneously reducing the size as well, right? If I talk about, right, and each token could be roughly equal to 3 to 4 characters in English language, right? And the total vocabulary size of GPT-4 is 100K to talk about in the context, right? Now let's look into the right hand side. I have 4 additional reference, guys. Okay, just like you have talked about, right? Let me go to this website called as Rapid Tables, right? Now, the interesting fact about this website is, you can see, you can put your text here, right? You saw me earlier, right? And I'm just trying to convert, right, this text. I can just share it with all of you here, just in case you guys are interested. Please feel. Yeah. India has Vyomkesh Bakshi. Yeah, Rishikesh sir, very nicely said, huh? Exactly, sir. How many of us have seen that? Doordarshan में काफी आता था. Vyomkesh Bakshi. Anyone? कोई देखे? Yeah. Oh, nice. Ankit sir
What
ने
is it,
देखा.
Saomya? I'm not getting this one.
Sir, Vyomkesh Bakshi is you're talking about Vyomkesh Bakshi, sir? Are you asking
Yeah,
about
yeah.
him? Yeah, sir.
Yeah.
He is the Indian Sherlock Holmes. You know about
Indian
Sherlock Holmes, right, sir? Right, sir? You heard about Sherlock Holmes, sir?
No.
Yeah, sir. Sherlock Holmes is a
detective
yeah.
kind of
So
thing.
he's a he became so you will feel like that guy has a, what do you say? He's a living legend. Where, sir, if I write Sherlock Holmes' address, people became so, what do you say? So fanatic about
221B
this guy. 221B Baker
Baker
Street,
Street.
London. This is an actual, yeah. This is, this actually, this thing actually exists. In fact, there is no character, there is no real character called as Sherlock Holmes. It is a fictional character, by the way, okay? But this address, right, has been converted into a Sherlock Holmes museum because people in Britain were so fanatic about that guy, the way he used to solve cases, right? If I talk about, right, so it's in a whole different league, right? So in fact, if you talk about, right, this guy has a website of his own. You see, there are
Okay.
blog posts of you'll feel like this guy, he's a, what do you say? I mean, he's a living person, right? See that it became part of the pop culture because of this, right? So, sir, he became very famous. So, when you
Okay.
talk about, yeah, Byomkesh Bakshi, he is the Indian version of Sherlock Holmes.
Okay.
BYO. Yeah, exactly. So, if I talk about, I think, yeah. So, I don't know, are both iconic fictional detectives. You can see, right, sir? So I think more or less you can understand. So that's the but it's really nice. The series is also nice. If I talk about old one, if I talk about just like Rishikesh sir mentioned, nice sir.
Old one series
Yeah,
that will come on the DD
Uh,
Doordarshan.
yeah, exactly sir.
so
My
Purana.
Soumya
name
sir,
is
हाँ sir बताइए.
uh, do we have any break today? Will we
अरे
getting
sir,
anything like that?
sir,
Break,
please
break,
please
sir,
take
break.
break now क्योंकि सर फिर मैं भूल जाऊंगा तो हो गया सर. So let's take break.
That's what I was
Uh,
thinking.
sir. So let's take a break and maybe we'll return after, what do you say? Maybe 10, 15, 20 minutes, I believe. Okay. So I'll start the timer here.
But 11:55 will be back, I think.
Okay. Okay.
Yeah,
11:55. Okay.
55.
Okay, sir. Okay, sir. I'll Yes, sir. Rishikesh, sir, you have raised your hand.
No, sorry, sir. Actually, I want to raise the hand in the second meeting. Mistakenly यहाँ पे raise कर दिया.
Oh, okay, okay. ठीक. All right. So are we all back? Is everyone?
Yes, I'm sure
Yes,
everyone
sir.
is
Oh,
fine.
perfect, perfect, sir. Thank you. All right. So shall we start off? शुरू करें?
जरूर
चलो,
Yes.
ठीक है सर, ठीक है सर. So, yeah, so welcome back, guys, after the break. So let's move forward with the things, right? So, guys, I think I shared that link earlier, right? If I talk about, and yeah. So, I hope you can all see here, right? So this is basically nothing but, what do you say? Um, the ASCII or the UTF-8 encoded, I mean, sorry, the characters, if I talk about, and the relevant conversion in binary. So I'm going to use the convert option here. So you can see here, right? So the word, I think everyone understands, right? That whatever conversion which you see here, right? Everyone, right? So what is this, by the way, guys? Everyone, can anybody tell me what is this first one, or what is this for? What is this number for?
1 byte.
H. It would be H.
Yeah, exactly, right? Yeah. So yeah, I mean, so this number, yeah, I mean, so that was the only question which I wanted to ask you here, right? So here, if I talk about, right, this is, I mean, the letter H, right, which is being represented here. Same way you have for E, there is L, L, O, and so forth, right? If I talk about, and let me just go to this, right? I say, let's say, um, character count. Let me just randomly use any of the tools. You can see here, right, that in fact, this one, characters without space, it says 48, right? Individual number of characters. Characters with space, there is 56, if I talk about, right? So I hope you can understand. So can you tell me how many of them would be here, by the way? How many digits will be there here in total? If the character count, I'll probably maybe reduce this. ये काफी बड़ा हो जा रहा है ना? Let's take this. This is a transformer session. Maybe I'll just, yeah, I'll keep that by Saomya, because this is having that tokenization and stuff, right? So I'm keeping that for now, right? So you can see that the number of characters is 40. Okay, it's easy to count up, right? So my question to everyone here is, if I write this, right, how many total digits will be there in the output? If I say convert, okay, how many total binary digits will be there in the output? You see the
40
count
into
here?
8. 40
Yeah,
into 8.
exactly, right? You're right about it. 40 into 8, right? That is 8432. Perfect. That is 320, right? So now if I talk about, let me just not use any delimiter, and let me just take this up just to give this count, I mean, give this on the perspective here, right? You can see, right? Just like how sir has mentioned it here, right? If I talk about, there are a total of 320 words. Sorry, individual digits, right? Now, understand this. Let me take this same example here. Let me go to tick tokenizer. Okay. You see the total number of token count as 10, right? It has only been roughly up to 10 tokens, right? I think you can understand. On the other hand, what I'm trying to tell you here is, if I represent the same information, right? You see, this is the transformer session or a transformer session by Saomya, right? If I represent this, right, in the form of binaries, it is going to take significantly, I mean, to be exact, 32 times that of the original number of requirement of tokens, right? Is it understandable? And everyone is able to see it here, right? Yes or no? Everyone got the perspective? Yes, no, maybe? Got it? So binary is not, what do you say, suggested to be a, what do you say, apt way of, what do you say, if I talk about tokenizing the things, right? Because you will get significantly higher number of bits to deal with. जितना कि आपका ट्रांसफॉर्मर का जो ओरिजिनल agenda tha, you would have used it to do some more meaningful things, right? But just because you are trying to represent it, I can do it. There is no wrong in doing this, by the way. Okay, I can create a transformer which talks in terms of binaries. But you see the problem here, right? जितना उसको contextual understanding करना होगा, the amount of contextual understanding it has. So you need significantly higher number of bits, right? आजकल के time पे तो the number of parameters which you have is more than 1 trillion, right? If I talk about, right? So I told you last time about GPT-3, which contained about 175 billion parameters, right? So जो parameters को function करने के लिए, if I talk about, right, they need significantly higher number of what do you say, things to first understand. Okay, it has to first see, okay, these 8 group makes one letter, right? Then it says that these few letters convert it into word, right? If I talk about, right? So I think you can understand the context, right? This is not readable. I think you understood the context, right? Let me go back here and convert this with what do you say, space as the delimiter. And now let me copy this and maybe I'll just paste it here. I think I should be able to have, yeah. So you can see, you have to first figure out that this is a letter, right? Then you combine these 2 letters to get words, right? I think you can understand, or maybe a few more letters to combine words. So I think you can understand each of the transformer block is going to, what do you say, struggle a lot first to get the contextual understanding, and उसके बाद वो उसको फिर word में convert करके फिर उसको then it is going to think about the meaning of the words and how each of them interact with, right? Everyone understood the point what I'm trying to make to this till this thing which we are discussing here, right? Now, so the number of significantly higher number of bits are necessary. You got the idea here, right? Now, there is yet another thing which you saw the problem here, right? Everyone understood, right? I showed you in terms of bits, right? And what is the problem? The problem is you are getting like huge number of bits, right? If I talk about now, next thing, on the other hand, I have something called as text finder. Okay, let me also share this as well. Okay, for reference in case you guys want to try it on your own, right? Let me just put it to perspective. Okay. All right. So I have this here, right? So now I think you can easily understand. The other way you can think of is, right, what if we took something in between, right? Like a binary to a decimal converter, right? If I talk about in the context, right? So for that, in the context here, right, let me just go to this, go back to the message, right? You saw that the message is now in binary. Let me copy this up, okay? And just maybe paste it, enter the binary numbers, right? In order to show it, I think I have to just take some of the, I think. I'm taking few of it, okay? I won't take the, you saw that it was earlier 40 into 8, right? So there will be 40 such things, okay? I think more or less you can understand. Let me just take it this till, okay, it is going to be over. So let me just, I hope everyone is understanding what I'm trying to do, okay? I am just making the bits apart, okay? Now I'm just going to convert it to decimal, right? I could have, everyone can use a program to do it, right? That's fine enough, right? But the whole idea here is to make you understand what is going on, okay? Now you can see the result of your, so you might be thinking, right? Okay, this contains 8 bits, right? I mean, it's fairly a large number of large number or a large portion, right? Why not convert this into decimal and then move forward with it, right? I think you understood the problem of, again, if I talk about in terms of just converting into raw decimal points, right? If you talk about, right, you will see a repetitive pattern, right? You can see number 32 getting repeated again and again, right? What is this 32, guys? What do you think 32 is? This 32, you see 32 here, there is 32 here. What is this 32, guys? What character is it?
Space.
What do you think? Yeah, exactly, right? So 32 is actually the space character. Brilliantly said. Yes. So you see, right, that 32 gets repeated quite a few number of times. And if you look into it, right, so if I talk about it, right, the number, so how many total numbers are there? You'll see roughly around 40 numbers, right? Because you saw me converting that many number of numbers to from binary to this. So there are 40 numbers here, right? Now compare that number 40 again with the tick tokenizer, which we got with only about 10 number of tokens, right? So what I'm trying to tell you in all of this, the moral of the story of telling you of all of this is that you can represent, it is up to you. If you want to take each of the words in terms of the binary representation, it is fine. But again, as I said, it is going to be highly repetitive and you might not be able to achieve the same level of accuracy which you get from GPT models than if you try to convert it into just the raw form as binary, right? Even then, even if you club them together and convert it to decimal, it is still somewhat, because you will see few of these numbers getting repetitive once, I mean, couple of times if I talk about in the context, right? So again, that will be tending towards more into the context of you're referring to those characters which have no special meaning to talk about or don't contribute enough to it. Okay, so I think more or less you understand the context. So that is why these two links are given, just to try out few certain iterations and stuff. Okay, so I think more or less you all understood why tokens were important to be the way they are now, right? So so that they become meaningful in the context. Okay, now moving forward, if I talk about, right, so you have tokenization is like breaking the language into Lego blocks, right? I think you can understand, right? Each token is a piece. The better the piece fit, the better the model can build the understanding around it, right? I think you can understand. So what you do is basically raw text, you tokenize using the BPE or byte-pair encoding, right? The token sequence which you get. And if I talk about the numeric IDs, I told you, do not think of numeric IDs as some kind of pattern, because it does not give you any pattern. It is just a representation. Okay, so you are just denoting a big chunk of set of characters into its relevant stuff, right? So it has nothing to do with finding textual patterns in the context of it, right? In a overall C, you are getting a pattern because you join those tokens together to get it, right? But it might not be altogether meaningful to you. Understood? Yes, no, maybe, guys. Everyone got the concept here? Shall we move forward?
Yes, definitely.
Perfect.
Yeah.
Perfect. Thank you so much, sir. Now, next thing, right? You saw that the step 1 and 2 are very clear, right? Now, next, moving forward, if I talk about, right, everything has been explained on earlier, right? So this is like a, what you say, summarization kind of a slide, if you talk about, right? Neural network training in the context, because these are the brains or the brainchild of what is going to happen, right? But again, before neural network training, obviously, you go through the process of attention, right? If I talk about, which we have discussed time and again from Aditya sir's session, my session as well, right? I think more or less you can understand, right? Now that the raw form is ready, it passes through the embeddings, right? Converts into embeddings, and then you have the attention and the feed forward network, right? If I talk about, right? So outputs probability distribution over the entire set of vocabulary, if I talk about, right? Let's have a look at it in a bit in the context, right? So how the training loop works, right? Read the token sequence. The idea is obviously, why are you reading it? You want to predict the token, right? The next token. Sorry, guys. compare with the actual or the ground truth, which you talk about, meaning what was earlier part of, is it part of the sequence, right? And then you move forward with the context and adjust, right? Or if I talk about, right, I think you can understand the context here, right? The gradient descent algorithm, if I talk about in the context there, right? So the loss calculation and everything, right? So because these weights get adjusted to talk about in the context of how you feed to the transformer, right? I hope this particular thing is particularly clear, because time and again we have discussed about it, more or less everyone knows about it, right? So you can see it's like training a parrot to guess what's the next word in a sentence, right? Over and over again, but you are doing it at scale, meaning because you have big set here, right? The set is very big. It's a huge set, right? So you are doing it over and over. In specific, GPT-3 uses 96 such layers. We are going to come across that. Okay, we are going to talk about that as well. We'll talk about numbers a bit. Okay. Afterwards as well. Okay, I'll talk about it. But you're doing it at scale, right? So I mean, a lot of it in the context in the pipe. So optimization at scale, you see, through billions of predictions across trillions of tokens, right? The model slowly refines itself to become better and better at language modeling. I hope everyone understands, right? Over the refinement procedure, right? It goes through it. Already you saw, right? The fine web data set is itself refined, okay, with the needed data, right? Then you further refine it with the interactions between the different words, right? Interplay of words, going through the neural network and everything, and then goes through it, right? Look into a little bit into the visual side of the network as well in due time. Just hold on for a few seconds, okay? I'll talk about that as well. So here's the thing, right? So you have a token sequence, right? It passes through the transformer model, right? I think you can understand what the model does. It predicts the next token which is in the sequence, right? Based on the prediction, right? Whether the prediction is good or bad, or whether it is inclined towards it, right? You compute the loss, right? If I talk about, right, or the basically the way of, if I talk about the gradient descent in the context here, right, which allows you to back propagate these losses, right? Basically, these are the two things which come hand in hand. If I talk about loss computation, and then you back propagate to the network, because it has to learn, right? I think you can understand the context, right? And then you have a updated model, right? That's the whole point. That's the whole procedure which we have seen so far, right? Now, inside the mind of a transformer, if I talk about, right, you have a few of these sequences, like the token sequence, right? I think you can understand, which is also, I hope everyone remembers, I used a word, a term earlier in my previous session, right, called as context window. Do you remember this, guys? Anyone? Do we remember what is this context window? Anyone?
Like window size, we are considering the context word, like how many words are there
How
before and
many?
after.
Exactly. Brilliantly said. Yes. How many words? So in a what do you say, state of the art models like nowadays, which you have, right? The context window can go all the way up till 8K. China has overthrown this thing as well, right? The context window is now 1 million, more than 1 million as well. I mean, they are progressing like anything. In fact, I think you can understand what is the equivalence of 1 million. Can anybody tell me how many words is it? 1 million tokens, if I talk about, right, that is roughly equal to a book, right? A giant sized book. You take the entire book as the context window, and then you can do it nowadays, if I talk about, right? Earlier versions, I mean, it used to be 1K, right? If I talk about, or the a GPT-2 model, right? If I talk about, right, had the context window of 1K or 1024 to be exact, if I talk about, right? So, I mean, it could see 1024 tokens. So, and this is roughly good enough, considering the time considering when it was released, right? It was able to write. I think you can understand. Everyone can. I think 1024 tokens. Don't you think it is more than enough to write a set of few passages? Would you all agree? One passage or one paragraph maybe containing like 300 to 400 words, right? And maybe 2 to 3 passages if you write, right? If you talk about, right? You can easily write that, right? If you talk about. Don't you think about that, guys? Is it understandable? What is this context window mean? Everyone, yes, no, maybe.
Yes, I
Am
think
I?
we can
Yeah.
sufficient one.
Exactly. Rightly said, sir. Right. So 1K roughly around can translate to having what you say. You can easily write, meaning it can keep in memory one big passage which it has seen earlier, right? If I talk about, that's the whole point of it. Easily keep that in memory, and then based on the big passage, it can predict the next word which is going to come next. Just one word. That's the whole point, right? And then you feed the entire sequence again, right? Minus that one previous word and then move to the next. Then again, you put the entire sequence again, right? The -2, and then you feed the sequence again to predict the fourth one, right? Or fifth one. Nth one, right? I think you can understand, right? So that is the benefit of having the context window, if I talk about. Brilliantly said by many of us, right? So I think more or less it makes sense, right? So I think you can see the output, it is like 100K class probability distribution. I think you can understand. I'm using the word class probability distribution. I think more or less you can understand, because each of them is a each of them has the say, right? So I told you about GPT-3 models containing 50K possible tokens, right? So each of the token has some probability distribution at the end after super refinement. Okay, this particular token has 20% chance or maybe 50% chance, right? I think more or less it makes sense to everyone. Everyone got the idea here? Yes? One out of those 100K class of predictions. Yes, no, maybe. Yes, no, maybe. Anyone?
Yes, sir.
Got it? Perfect. So one number of for every possible next token. Perfect. So next thing, if I talk about, right, we have few of the example predictions, right? So this is session, net, and movie. You remember the example which I took earlier, right? I think it was this. Where was it, by the way? Yeah, welcome to the Transformers, right? There was this, what do you say, example here, right? So the next word probably could be session. Session is given 4% likely prediction, saying that, okay, it has more higher chances of getting the word, right? Based on the context window which you have fed in, right? Yes, no, maybe, guys, right? I think that's what you are talking about here, right? So the next word is like welcome to the Transformers dash. That dash is filled by session, right? So welcome to the then you feed the entire thing again. Welcome to the Transformers session dash by or something in those lines, right? I think you can understand, or you can put exclamation sign as well, just to say that the sentence completed as well. That is also grammatically correct, right? If I talk about, but based on the contextual understanding of the previous tokens, it moves forward, right? Yes, no, maybe, guys, everyone understood the deeper significance which we are talking about here. Everyone, yes, perfect. Thanks so much, sir. So now we have transformers use self-attention, just like how we have come across this word quite a few number of times. Each token can look at or interact every other token to decide what matters in the context, right? That's a pretty much forward looking into the context here, right? So you have these, right? Token influence each other, and then deep dependencies across longer sequences, because you have a big passage of text, right? If the context window is 8K, you have 8K tokens interacting with each other in the context, and then each of them has a say of, okay, you decide, I mean, the next token should be this and stuff, right? If I talk about. So I think you can understand, for every forward pass which makes a choice between those tokens, the full vocabulary of GPT-4, that is the full vocabulary of GPT-4, right? This means one particular step is basically nothing but one prediction out of those 100,000 possibilities, right? I think more or less it makes things understanding, right? So basically, we saw that, right? In fact, numerous times, Aditya sir has also talked about it. It's nothing but a giant math machine. In fact, how he likes to coin it, the term, right? It is basically a big function, right? If I talk about giant function to talk about, right? A giant mathematical expression to go through in the context of, which is a fusion of probabilities, matrices, multiplication, whatever you do in the context there, right? So it is a giant math machine, right? So basically, you should understand one thing, guys. It does not understand. Basically, it is probabilistic text generator. I think you can understand that, guys. Okay. So sequence, token sequence, you have transformer core, you have the token probabilities, and out of that, you take some kind of a top choice. There are different ways of choosing, right? We'll talk about that and stuff in just a few seconds now, okay? But you take one of those choices and move forward, right? So let's move forward and talk about, right, the art of generation, right? In the context here, you see that the tokens, you say the top choice, right? That's what we are going to describe here, right? In fact, the context of inferencing, right? If I talk about, right? So under this, right, inference, I use this term, right, earlier, right? I told you. Inference simply means generating a token at a time, if I talk about, right? So each step predicts the next token based on everything that came before. And when I say everything, meaning the context window, everything means whatever context window it has in the previous one, right? If I talk about. So input you have there, right? If I talk about, right, you can see, right? I think you saw me showing that, right? So you follow these steps, right? A very generic introduction to the context which we are dealing with here, right? So let me just cross these up for the stuff, right? Now, there are few of the decoding strategies. Okay, I think you can understand the context here because I told you earlier, right? Just now I told you the word as top choice. This choice can vary. What kind of choice you want, right? It can vary, right? Okay, and for that, this is another link. I think, in fact, you might have seen it earlier. You remember I have showed you that transformers explainer earlier, guys. Okay, so I showed this to you earlier, right? In the context, right? Now, in case you might have, you don't have the link, right? Let me quickly share this link again with all of you. Come on. Yeah. So, let's see this. Guys, is the screen freezing for all of you?
Come again, sir. Is there any
Is the
problem?
screen? Yeah. Is the
Yeah,
screen
it
freezing?
is. It is.
Okay.
No,
Okay.
change the screen.
हाँ अब दिख रहा है सबको? Is it visible?
Yeah.
Okay, okay, sir. Thank you so much. यार ये actually it is a मुझे इसको चलाना नहीं चाहिए because you know when you go to this website you will see that it actually downloads GPT-2 for you locally. Okay.
Yeah, right. By default.
तो हाँ तो वो जो प्रोसेस है इट इज अ वेरी मेमोरी इंटेंसिव प्रोसेस तो ये काफी स्लो करता है बट स्टिल थोड़ा सा वी कैन एटलीस्ट गेट अ वेग आइडिया अबाउट व्हाट वी आर टॉकिंग अबाउट ओके now let's move forward, right? What I want to talk about, okay, is a decoding strategy. You can see that number one strategy it says as greedy decoding, right? Meaning always pick the most probable token fast, but you will find it repetitive because, guys, I think you can understand, right? There are very few likely tokens. Suppose aapne you want to complete a passage, right? But you might have seen that you might have seen after few turns, right? These models, right? They tend to give same kind of output, right? So they try to generate same kind of an output, right? So you might see a repetition in the pattern, right? If I talk about, right? So they will be kind of repetitive because you are saying greedy decoding. Greedy simply means like, sir, I think Aditya sir mentioned it in our session last time as well, right? If I talk about greedy means you become greedy to talk about, okay, whatever seems the best possible thing, only take that rather than being much probabilistic, right? That you have 10 choices, pick anyone from there, right? You are saying that pick the most likely option from there. There is a difference between the two. Everyone agrees to that? Yes or no? Everyone understood what I'm saying about, right? So I'm saying
Yeah.
that, yeah, everyone got the context here, right? Especially because I think, sir, you, especially for others as well, guys, okay? Because sir used this term in his session, the greedy decoding as well, right? If I talk about, right? So hopefully this is particularly understandable by all of us, right? If I talk about, right? Now, moving forward in the context which we are describing here, right? So you can see here, right? You take the most likely token, right? So if I talk about, right, rather than talking about in the context, right, you take the most likely token, right? So maybe visualize, right? To visualize would be most favorable token out of the sea of possibilities or probabilities, right? So that is what is meant by greedy decoding. Okay. Next way you can do sampling, right? Basically randomly sampling. This randomly sampling means basically in the terms of what you say, a transformer, wherever you see large language model, it is mostly referred to as this parameter here. Everyone can see this, right? The temperature parameter. Got it? Temperature parameter. And if I talk about in the context there, right, if you look into, right, so you see randomly pick from the top tokens, right? If I talk about, it adds creativity. The proper word would have been not sampling, it would have been temperature. I should have used one of the decoding strategies using sampling using temperature. That would have been a better strategy if I talk about, like, my mistake in putting the term there, guys. Okay. So I think you can understand the temperature strategy. One of them is that, okay. The third one, we'll talk about these two, okay, in just due time. Okay, I'll show it to you how it changes. The third one is top K or top P probabilities, if I talk about, right? In P stands for probability, top K is the number, okay? So K, if it is 10, that means you are saying top 10 out of the top 10 most probable tokens, choose one from it, okay? That is top K versus top P simply means if I talk about in the context of probabilistic terms, right? Where you talk about having the cumulative, what do you say, probability CDF. Basically, you take the cumulative probability of the things, and then based on it, I'll show it to you. It will be easy for you to understand. In the, I hope everyone is able to see the screen, right? The transformers explainer screen. Okay. Now you see this temperature parameter. Okay. Observe very carefully, guys. Okay. You see the temperature is set to 0.8 for now. Okay. I want you all to pay attention to this area. Okay. Everyone, are we all there with me or slept off, guys?
Yeah.
Yes, yes.
Okay.
Yes.
Perfect.
You.
Yes,
Perfect.
yes, yes.
Yeah. Perfect. Thank you so much, sirs. So I want you all to pay careful attention to this part, okay? Because this is the final stuff which is getting out of it, okay? So look at this. The moment I do this, can you see what is happening? Do you see this? I'm increasing the temperature, okay? Versus I'm decreasing the temperature, okay? Can you interpret what you are seeing here? Did you follow up, everyone?
So like when you increase the value, the probability value is decreasing. Like percentage value is decreasing.
So yeah, sir, another important thing to observe, look at the, I have taken the temperature as 1, which is ideally basically nothing but, the temperature factor is during the time of the output, right? If I talk about, right, you will see this. Can you see this here? Let me maybe talk about in terms of the temperature. Okay. I don't know if I talk about here, let's say logits. यहाँ पर आपका does it give it? No, यहाँ दिखा तो नहीं रहा. Anyways, okay. So the final softmax, right? I think more or less you can talk about, right? The final softmax function, if I talk about, right? यहाँ पर कहीं ना कहीं दिखाता था यार, मैंने पहले भी देखा था।
So that's on the left hand side, the bottom. You could see that one value is given for the temperature. Epsilon power to the Z score divided by the temperature. Yeah, that one. Yeah.
कहाँ पर सर?
हाँ वही जहाँ पर arrow है आपका वो temperature divided by 1. I guess you have set it to 1, right?
Yeah, exactly. Sorry.
Yes.
Yeah, exactly. Yeah, it does not give. I was thinking, sir, कि मुझे actually यहाँ पर मैंने वो भी देखा था, formula भी देखा था, but it does not give me here.
Yeah,
But
formula
still,
like epsilon to the sorry, e to the power of
exactly.
it is
E to the
just
power of
a Z.
I just wanted to
Yeah,
show them the
softmax divided
softmax
by
formula.
temperature.
Exactly. So softmax divided, मैं वो formula दिखाना चाहता था, but मैंने कहीं तो देखा था सर, यहाँ पर मुझे याद ही नहीं आ रहा. But anyways,
Yeah.
thank you so much, sir. Yeah.
Maybe
So
if you
exactly.
could remove the value.
Exactly. फिर पता नहीं सर, रहने दीजिए, सब दिखा रहा है. But everyone recalls that softmax formula, which just now iterated correctly by sir as well, e to the power of, so you take minus x, whatever that xi, and you divide it by summation, right? If I talk about, right, I to that entire thing, you take that e to the power of that, right? If I talk about, right? So you do that, right? After doing that, in the context, right? No, if I talk about, right, the logits, sir, ये actually softmax नहीं है. Oh, that's why it is not showing it. I'm sorry, sir. I'm sorry. Softmax आप यहाँ पर apply कर रहे हैं. That's fine. Okay. So यहाँ पर हम लोग क्या बोलते हैं? Scale logits हैं. ये raw values हैं, right? So we are dividing these logits by the value of the temperature. Doesn't matter. You can do that after softmaxing as well, because आप anyways divide ही कर रहे हैं. चाहे आप पहले करो या बाद में करो. Depends on it, right? So if I talk about in the context here, right? So more or less, I think if everyone understands the context here, as the temperature is divided by 1 here, and you can see that the number gets divided. Can you see this all, right? So I've taken, what do you say? You can see the temperature taken as 0.4 in the context here, right? And can you see the simultaneous change on the right-hand side as well? Look at the softmax here. It is giving visualize a very high probability. Compare it with create, see, make, and easily, right? If I talk about, right? So these are given lesser probability values. And I told you, right? The very first thing which we were discussing here, that is the greedy decoding. It's something like this. Is it understandable? You are getting greedy, that you say that do not import, do not, by the way, temperature is basically nothing but creativity. You control creativity using temperature. Okay. And by the way, along with creativity, you can use, the technical term which you use is called as entropy. You use the word entropy. I hope everyone recalls it. It's a physics term, if I talk about, which deals with randomness. Entropy talks about randomness. Okay. So you add more, the more you increase the temperature, meaning AKA, you are increasing the temperature. The more you increase the temperature, you are AKA doing, what do you say, increasing the randomness, AKA you are basically increasing the entropy. Is it understandable by everyone? Yes, no, maybe, guys. These terms can be used, can be used interchangeably. Perfect. So you can see, guys, that as the temperature decreases, just look at this portion here, right? As I increase the temperature, you can see, guys, that it gives, like, the probability gets shifted again and again, right? If you talk about, right? And I think it is safe to say, right, guys, I think you remember Aditya sir, last time when he took the session, he told a very important and very interesting and very nice point, that the temperature parameter generally never crosses, 1.5 to 2, if I talk about, right? There is a subtle reason for it, because theoretically you can increase this. Okay, let's see what happens if you increase it. Okay, I've taken the number as 2. It is still relative, right? You can see 32% probability, 22. You can see these bars getting more and more, right? Now let me increase it. Can you see this, guys? What is happening here? Can anybody tell me what is happening here? What do you think is happening here? As I increase the temperature, which is senseless to do for temperature equal to 8, why am I saying it is senseless, guys? Can anybody tell me that? Anyone? Quick, guys. What do you think? Whatever you think. Yeah.
Like very short
Maybe after content, there will not,
sentence.
there might be no creativity.
And sir, exactly. You see that these probabilities also, right? They are also like, what do you say? They are having almost very equal probabilities if you talk about, right? I mean, in the context, like there is nothing like you are giving preference to something, obviously. So obviously, it might be possible that although these are top 5 choices, if I talk about, right, let me increase the samples and stuff, right, if I talk about, right, so you'll see that more or less many of it, right, you see the word build, right, users to build, right, you can see, right, these all make sense, right, but if everyone is given the same kind of a what do you say, soft max, right, without having a lot of variability, then it becomes a challenge as to what to pick, right? It might give, so for few turns, it might be making some sense, right? So, the reason is here, very soon, if you keep on increasing the temperature, it is very well possible that whatever question you have asked, right, initially whatever question you have asked, the LLM becomes so creative that it even forgets the question it has been asked, and it introduces, because it has limited context window, right? So it it introduces things which are nonsensical, maybe to the question, but it might be doing a good job. It might be actually doing a good job in its own sense. But for us, because we ask the question as, suppose I ask the question as, what is the capital of India, right? It should, and give a brief description about it. Okay. So it says the capital of India is New Delhi, and it gives a short description. And suppose the context window is 100. Okay. What happens after that? You have taken the temperature as 8. Okay. So after a few turns, you will see that it completely strays away from the path. So you started with India and Delhi, right? It says something about Delhi, and all of a sudden it goes to world politics and add something nonsensical. Why? Because it is only a interplay of words. You can see, right, these all words have equal contribution, right, to say, right, maybe somewhere it sees the word politics, and then from there it takes a huge turn and then goes to politics. Do you get it, guys? Where the original idea was to just tell about what do you say, the capital, but it goes off track and gives a lot of things which are nonsensical. समझ में आ रहा है सबको? Is it understandable how things work in the context? And that is why I say that for many of the models, you will never see a value greater than 2, by the way, okay? Because you can see that even in 2, if I talk about, and by the way, the number of sample size is also taken relatively lower, if I talk about, you will see that there is still a kink, right? 18, 12, 10, 7. So it's a good distribution to talk about, right? But as you decrease the temperature, it becomes more and more, you can see, right? I think you can understand the number. It will always, I think, if it is given a temperature of 0.2, right? What will happen, guys? I think you can understand it is going to take, what do you say, visualize, and then whatever tokens come up next, right? It is going to take those tokens, and it is possible after a few turns, right? It might, because it has run out of vocabulary, right? It is going to repeat those words again and again, and it becomes gibberish again. Do you understand? For a short passage of maybe, let's say, 100 words, this is fine. You can be greedy. Okay, you can, because it is you can be greedy about, because you need as much context as possible. But the moment it forgets or has no more vocabulary to contribute to, right, then you have to be creative. That's the whole point. समझ में आ रहा है सभी को? Yes, no, maybe, guys?
Yes, sir.
Yes, sir.
Perfect.
Yes.
Perfect, sir. Now you see that temperature parameter. Okay, I'll keep it to 1. Okay, that's the whole point, right? Where you neither lose creativity nor you do something like, I mean, where it's optimum. Okay, but you want to be poet. Okay, you have seen, right? Do you know what is the difference between normal English text versus a poem, guys? You might have read about Rabindranath Tagore's poems and many other poems, right? Many of the they are a bit of philosophical, right? If I talk about, right, you make so much of vivid picturization, right? I mean, you will see that, okay, you'll have to go to, and you might have seen, right, the creativity of a poet is very different from that of a scientist, if I talk about, right? Because scientists talk about facts, but here you keep your mind open that, okay, this line can be interpreted in 10 different ways. Okay, in this line you might have seen, right, the teacher asked, what is the poet trying to say in this particular line, right? Something kind of a sentence like that, right? A poetic language, right? So who is this temperature for? Like, temperature equal to 2 is for those people who want creative answers, right? You got it, right? I hope you can understand. Everything has a use case, okay? So you see that temperature equal to 0.2 has its own use case. Yeah, someone says that give me in under 100 words, okay? Then you can use temperature equal to 0.2. Then you say, someone says that I want a, what do you say, 1,000-word essay wherein you talk about, okay, be probable, I mean, the choice of words, you can have some freedom to it. Then you can have, what do you say, temperature equal to 1 and temperature equal to 2 for creating nice thoughts about the things. Like, for example, you're talking in terms of poetic language, right? You got the idea, guys? Everyone understood the concept here? Yes, no, maybe?
Yeah.
Yes, perfect. Thanks so much, sir. Yeah. Now, moving forward, you have the sampling. Okay. The third technique here, which is like top K versus slash top P, right? If I talk about, right? Top K, I think you can all easily understand. Okay. If it is already selected as top K, meaning I'm talking about the number of samples. If the number of samples is 5, you sample out from the top 5. Easy enough to understand, guys, right? Top K, right? You what do you say? Cut it off to that particular extent, right? Now, same way, top P, if I talk about, right, this deals with probabilities, right? In fact, it deals with cumulative distribution, okay? When I say cumulative distribution, I think you can understand, guys, okay? You can see, can you see the moment I do that, I say, I'm taking P equals to 0.5. Can anybody explain me this? What do you think P equals to 0.5 means here in terms of CDF? क्या हो रहा है इधर? Anybody?
I will say again, rather selecting the first token, like first and token, we are
Okay,
going
sir.
with the probability. Like we are doing sampling with the based on the probability.
Yeah, perfect,
Like
sir. And sampling with probability, just like how you said. And by the way, guys, did you notice one more thing? The moment I choose top P, there is something like this which has appeared here, right? It says sum equals to 0.5. Why? It says 0.5. If I talk about the probability distribution I'm taking, the cutoff is, so you remember, right? Aditya sir, what do you say, took the session earlier. He talked about the CDF, right? This simply means you have the top, these are all probabilities, right? You sum up all the probabilities and that is taken as the window, active window. You can see this, right? I think you can understand the context here, right? You can see 0.24 plus 0.11. How much is it, guys? 0.24 plus 0.11 is 0.35, right? Everyone agrees, right? 0.35 plus 7, meaning 35 plus 7 is how much? 36, 7, 8, 9, 10, 11, 12. 42, right? Yeah, 42 plus 4 plus 4, that is 50, right? Everyone agrees? So you understood the context here, right? So you have, oh, someone nice. Your sir, your sister is also learning, is it? Nice.
I'm actually so fed up. She is trying to answer you all the questions. So when you
Oh,
ask me something,
nice.
she just said that you should be trying to read on what you see on the screen.
Okay. Okay. No, I'm very
Wow.
happy. That's great. You're very intelligent. Good. Nice. So yeah, exactly. So you just like how our little friend also said, right? So 42 plus 8 is 50. You get zero point 0.5 as the probability here in the context, right? Same way, look at this. The moment I change the slider, right? Look at this. I say 0 0.7 for the probability, right? Look at this now, right? 24, 11, 7, you have 4. You will add this up. You'll get the cumulative probability density, okay, if I talk about, right, and it turns out to be 0 0.7, right? So all of these are taken as the active windows, okay, and from this one gets the same. Is it understandable, guys? Okay, easy to interpret, because this visually appeal, like it is really appealing to look at, right? If I talk about, and if I just reduce this, you can see that how temperature is behaving here as well. Look at this. I have taken all three of the parameters. You see, by the way, this is should be equal to or greater than, right? Sir has already also told it numerous times earlier, right? So it is equal to or greater than 0 0.7, right? So you can see the sum coming up as 0.73, right? Because the sum is not exactly 7. Had it been 7, it would have taken that, okay? But the sum is higher than that, right? So that is in part of the active window. Is it understandable? Yes, no, maybe, guys, all of us.
Yeah.
Perfect,
And
perfect.
yeah,
Yes,
and
sir.
and also, sir, like if we really wants to talk about the p value over the k, so without the cumulative, it doesn't even work, because until and unless
Exactly.
you do not have the distribution of those
Exactly.
probabilities, or let's say the all the cumulative, you might not, it
Exactly.
might never be
It is
possible for us
meaningless.
to create that the creativity, right? When
Creativity.
this
Exactly.
temperature increases, reduces, like that.
Exactly.
So even
As
if we are
the temperature.
increasing it, yeah,
Uh-huh.
we get the bigger basket, like with the more
Uh,
tokens for
More
being
to.
more creative.
Exactly. Exactly. जितना हम उसको flexibility देंगे, it becomes more creative in that aspect, right? So hopefully this makes sense to everyone. Everyone understood, right? I'm trying to make it as simplistic as possible, and just like how Aditya sir also mentioned here. Is it understandable by everyone? Yes, no, maybe, guys. Others, समझ में आ रहा है? Okay, perfect, perfect. That's great. Yeah, it also says here, right? If I talk about, right? So in the context here, if the cumulative probability density is less than or equal to, you have 7, right? If I talk about in the context there, right? 0.7. So this is exactly what I wanted to talk about. So आज के time पे, guys, it's just the size has become bigger, but the concept or the foundation has remained the same. Okay, you have these things which interplay in the overall context. Yeah, Ankit sir, you have something to add upon or ask.
I just want to discuss. I am not able to
Right.
understand one thing.
हाँ
Like,
जी,
if you know, then please share with me.
ठीक है सर.
So that is clear, na, that we are getting the cumulative probability, right? The
हाँ जी
whatever
सर.
P we are giving, right? So for
Right sir.
example, if we are having four tokens, for example, four token has been selected with the help of that zero point 0.7 we are giving.
Right, exactly sir. हाँ, ठीक है.
Okay.
4
Now
token.
let's
हाँ,
consider we
0.7.
are getting the first four token. So these are
Mhm.
visualize, create, and then see, make.
हाँ, exactly. So
So,
visualize, create, see, make, and easily. If you
so
take 5 sir, 5 है ना sir? So top 5,
the
क्यों क्यों
five.
क्यों 5 है? Yeah, हाँ, because sir, the sum is 7 3, right? I want cumulative probability
Like
density
in that,
of that.
like in this particular case, we are getting five. So it doesn't,
हाँ,
like, it is not like now we are fixing top five or top four. It's based on the p
हाँ,
value, maybe six, maybe five, maybe four.
हाँ, sir, it will be top 5. हाँ, yeah, it can be top 5, top 6, top 7, but वो top से ही होगा. You're right about it. Exactly,
Like
sir.
the cumulative
हाँ,
probability must be like we are going to keep selecting until we are
हाँ,
getting the cumulative probability greater than 7.
exactly. You are going to do
Now,
that. और sir, हाँ, इसमें sir
now
actually
the
इसका कोई
question is,
contribution नहीं है. हाँ, yeah, go
now
ahead.
like my doubt is, Because we are getting all these value na like point, for example, first have 0.35, second have 0.17, then 0.17 again, like that. So in the end we are getting 0.73 or like whatever the probability for the last, the total cumulative probability. Now
Mhm.
if we are going to calculate their uh, probability na,
Okay,
this
sir.
time I'm getting one doubt that we are not getting the overall probability out of one. If you are able to understand what I want to tell you here.
Acha, हाँ. See, sir, I
So this
understood.
will
So, sir,
like confuse the model, or I'm not able to
हाँ.
understand that part.
Sir, yeah, nicely iterated. Yeah, you are right that the sum is not one in this case. You're right about it. Because sir, the way we think of probability is out of one, right? If I'm not wrong, you are referring to that, right? So, but in this case, we are saying that I mean, you see that the sum is 7-3. But you, sir, did you observe one thing, that there are these as well, but they are cut out. Can you see this, sir? These are cut out. Can you see this? I'm just
Yes,
hovering over
yes.
them. Yeah. So what this means is, sir, actually, it is one. The overall, what you say, overall probability is obviously one, but during the time of contribution, you cap it. Meaning, it is like, sir, you have a big window, okay, sir, and उस window में आपने बस इतने में पैच लगा दिया कि मुझे बस इतने ही पैच में जो जो है I want whatever is existing I'm going to pick from there. और जो दूसरा, sir, it is like masking. You don't see the others, but they exist. Fact is, they exist. The overall probability has to be one, but you are taking to that point, which is nothing but where the cumulative probability is set to either what you say within 70. If I talk about in the context, right, wherever that number ends, you got it right, sir. So you are taking that
I
as
think
a
I have
bracket.
like, okay, I will check that. Like these calculation that I'm writing in the chat. So can anybody help
Okay,
me to calculate that? What are the like exact value we are getting? So it
one
is
second,
like
sir.
70 or 73. That is my doubt actually. So like the last one is different, 0.08. So if we are getting answer from, so let's go with the point
Uh,
1473. It's
yeah, Ankit sir,
19.17.
Ankit sir, there is, I just want to add up here that you have divided by 0.73. 73 basically it's a, the cumulative probability actually. So why exactly we are dividing?
That
I'm
is the
not
window,
getting that.
na? That is the
No,
window.
sir, no,
Now
sir, no, sir,
we are.
no, no. You do not have to calculate as per the window actually, because if you are going to create combination, it should be a dot product. We actually cannot create, cannot divide this cumulative probability by you cannot keep it as a
Just
denominator over here.
give me a minute. Like what is for the first now? 0.43. 0.43, 0.70. We are getting 0.61. If I do with 0.73, then I'm getting point. So I think it's 73, not 7. Or like the whatever. For example, we are
It
choosing
is,
in
yeah,
point 0.7, but because
point.
this is exceeding like 73 is the last threshold. That's why we
Yeah.
are choosing 0.73.
क्योंकि सर you know sir, the reason why you are taking that is because sir वो जो cumulative है ना sir, you are adding, okay sir, if you do 43 plus 14 plus 8 plus 4 plus 4, then you get
नहीं नहीं नहीं,
73,
अभी क्लियर हो गया
right
मैं.
sir?
तो
समझ में आ गया ना सर?
I just want ना कि why exactly we are getting this 59 19. So
हाँ
अभी अब 0.7 से वो नहीं आ रहा है, वो 0.73 से आ रहा है.
हाँ 0.73 से आएगा सर,
हाँ.
क्योंकि सर सम है ना सर, आप वो सम लिए हो,
Yes,
राइट? बिकॉज सर 0.7 अगर आप
we
लेके
have to
चलोगे,
divide.
वी,
हाँ,
हाँ हमने सर,
सही है.
हमने या इन दैट केस, या जस्ट लाइक हाउ टू टॉक अबाउट, राइट, जस्ट लाइक आपने जैसे बताया 70% हम अपना थ्रेशोल्ड लेके चल रहे हैं, बट देयर इज नो सच बाउंड्री टिल विच I mean 70 is existing until, right, if I talk
The
about.
last
So
one, it may be 0.76, 7371. So like that will decide.
Exactly. You got it right. Exactly, sir. Exactly. So उसी basis
Yes.
में you get these numbers on that, right? Roughly around if you talk about that, right?
हाँ
Perfect.
हाँ.
Yeah. Nice, sir. Brilliantly iterated, sir. That's great. So I hope that's particularly understandable by everyone, and the confusion is also a bit clear in the context. So you get the percentage contribution in the context here, right? So you can see that 0.04 obviously is almost half of the 0.08 if I talk about, right, in the context of the numbering in the context here, right, if I talk about, right? So I hope you can understand the context which we are referring to here, right? So now moving forward, right, that's the whole point to be discussed about, right? Let's move forward. I hope this decoding strategies are a bit clear to everyone, right? Everyone, shall we move forward? Yes, no, maybe?
Yeah.
Cool. Perfect. Thank you so much, sir. So I have, I think you can see there are a few of the generation examples, right? I mean, there are a few of these, right? Some samples and stuff, right? Nothing critical, right? Few of the previous tokens, you pass it through the model. The idea is to, predict the next token, right? And then you sample it out, and then obviously you add the token to the final stuff, right? Now, talking about GPT-2, right? The next big thing, right? In fact, it's like the scroll which actually elevated everything, right? You know, in the space which we have been discussing so far right now. Okay, so in the context here, right? So you see that here, right? If I talk about, right, unsupervised multitask learners, right? If I talk about, right, language models, if I talk about, right, and you know, as we have discussed couple of times, it was a milestone, by the way. It was not fairly a large language model like GPT-3, but it was still a milestone because you started, right, from there, right? A proper, the people thought of it like, okay, now this can indeed sort out a big problem in the context which we are discussing in the sea of possibilities, right? So you can see, right, generate human-like text, if I talk about, translate, summarize, whatnot, right? Obviously, it felt like magic, right? And if I talk about, GPT-2 was a fairly smaller model. By the way, the base variant of GPT-2 was 1.4 billion parameters. 1.4. So GPT-2 XL contained a fair little bit of a higher number of parameters, like 1.6, which you can see here, the largest open access model of its time. You can see, guys, they made GPT-2 open access. That means you are still, if you want to go ahead and download it, right? Just like, what do you say? Guys, have you heard about DeepSeek? Has anybody heard about DeepSeek? Yes, no, maybe?
Yes.
Perfect. So DeepSeek, again, if I talk about, right, again, one of the promising models, right? In fact, you know, when DeepSeek came, it broke the internet, especially the state of the art models of those time struggled in front of it, because, and on top of it, it was open access. You can download it. By the way, it's from China, so many of the people have trust issues with DeepSeek because of its origin, right? If I talk about, right? So, but however, it's one of the best models which you can think of being created of its time, right? Now you can see, right, largest of its time was trained on a massive 100 billion tokens at its time, if I talk about, right? Nowadays, you have corpus of 15 trillion, right? Fine web data set is 15 trillion tokens, right? But of its time, 100 billion tokens used to mean a lot, right? If I talk about, right? So massive web scaled data set, if I talk about, right? And the context window, I told you earlier as well, right? 1024 token context. I think everyone understood, right? I referred to this as well, enough to write full paragraphs with consistent tone, right? We saw that how it, what do you say, cool enough to look into, right? So I think you can understand it could do a lot of different things, right? write fiction, translate, right? Some unimportant facts could also be fabricated easily by GPT-2, right? All without even fine tuning, if I talk about, right? Fine tuning was not in picture those days, if I talk about, right? The time when it came, right? Fine tuning was, it came up, it is relatively new, by the way, guys, okay? So I think more or less you can understand the context here, right? And it proved that scale plus prediction, you can see scale plus prediction alone could unlock general language intelligence, right? Because you are doing nothing special here, right? You saw, right? The transformers network is not so special. The way it is created is special. You got it, right? So if I talk about, right, that's why in the context, right, the number of parameters it says, right, you're not doing some complicated refinement and then doing something there, right? It's just feeding large data, and you have enough number of parameters which can think of the things and then move into. So you have 1.6 billion parameters. That's enough to talk about a general intelligence, right? If I talk about, right, that is why it says scale plus prediction alone. You're not doing complicated. What do you say? You're not putting intelligence there, right? So it's just scaling. It was bigger scale because it was really big, right? If I talk about, right, big office time, right? Not currently. Currently, it stands nowhere in comparison to modern state-of-the-art models, right? If I talk about. So yes, you see here, right? So we're not releasing. I mean that OpenAI. If I talk about afterwards, right? After they saw the potential of it, things have become blurred. Okay, I mean they haven't released publicly GPT-3 to be downloaded as weights. GPT-4 has also not been released publicly. You can use it, okay, in terms of services, but that's, as I said, right? I mean, a fun fact here, right? It was the first time an AI model felt too powerful to be released in the public, right? Because it had that general language intelligence capability, right? So if I talk about, right, and obviously, guys, I think you can understand, because if something has general capabilities, right, it will raise ethical concerns. I think you can understand, right? Because ethics will be compromised because the data which you filter it from, and suppose it has been trained on unethical data, right? If I talk about, because 100 billion tokens is a very huge data, right? Could be hacking, hack related stuff. It could be XYZ, how to make bombs and everything, right? I mean, you can talk about it, right, in the unethical space, right? So it raises ethical concerns as well, right? If I talk about in the context, right? Data from the dark web and stuff, if I talk about, right? Huge segment altogether, if I talk about in the context, right? So I think more or less you understand the ethical concerns if I talk about in the context here, right? So now you saw the earlier aspect, right? If I talk about, let me just say, yeah. Guys, it's one. Please forgive me. I'll take few more minutes extra. मैं थोड़ा conscious हो रहा हूँ time के लिए because sir, actually we have lots to cover. तो मुझे I don't want to miss out on any of the small details which I want to. I hope, sir, before I go forward and stuff, I'm hoping, sir, is the contextual understanding the way we are discussing here and stuff, is it good enough, or like how is it for everyone? Thanks so much, sir.
It's going good.
Perfect.
Good,
Thank you
good.
so much. Yeah. Okay, sir. So that's why, sir, I would like to keep it a little bit slow. मुझे थोड़ा सा और time दे दीजिए, and then we can all go for lunch, maybe.
नहीं पता है हमको, सौम्या सर आ रहे हैं तो हमको भूखा ही रहना पड़ेगा।
अभी और एक हफ्ता तो बाकी है, और एक हफ्ता हमें यहीं पर बैठना है अजीज सर, उसके बाद ही खत्म हो जाएगा।
No. Okay, sir. Yeah.
Carry on.
So guys, yeah. So you guys saw that we talked about GPT-2, state of the art model of its time, right? When it was released, right? Then came GPT-3, which was the actual fire in the pit, if I talk about, right, which changed a lot of things, which you look into, right? By the way, before we move to GPT-3 and talk about a little bit more into it, right? In fact, you look into the slide which you see here, right? How many brains are there? It's basically, I think you can understand, right? Refers to the neural aspect. Okay, we'll talk about the neural network and stuff a little bit. Okay, but before I move forward, right, let me give you a snapshot as to how the GPT-2. I told you, right? GPT-2 is a model which is available for the public to train on, right? You can also do it. Okay, but let's see, even by its standards, even being smaller, right? How, I would say, difficult it is to train that, considering modern standards as well. Okay. So you see, what you see on the left-hand side is a few of the hyperparameters. These are the hyperparameters. By the way, guys, can anybody tell me what is the difference between hyperparameter and a parameter? Quick. Anybody. I'll just zoom in here. I'm saying these are hyperparameters. Okay. And I say parameters. What is the difference? What do you think?
I think my point of view, the parameters which we are taking from the input side, the hyperparameter which we are which can be modified during the training of model optimization, while computational.
So that is hyperparameter, right, sir? The one
Yes.
which will be changed
Parameter,
during
it is like which we are taking as a input parameters, like input values.
Okay, sir. Okay.
I don't know,
nice
right or
try,
wrong.
Raja sir. Yeah, right. Nice try, sir. Raja sir, I'm very happy. Anybody else with any other thoughts? Very nicely said.
Weights are the parameters, hyperparameters that can be the trainable are the parameters that we can train and they change with the loss and all. Hyperparameters are something that we can do that we can use for the better output. Depends upon the things.
Perfect, sir. Perfectly said. Perfectly iterated. Sir, just like Aziz sir has just mentioned it, Raja sir, whatever you said, whatever exactly which you said, sir, it is the little bit of an exact opposite of it. So, in theory, if I talk about, just like how Aziz sir mentioned as well, so a parameters are those which get trained during the time of during the running of the model. So you see that back propagation happening, or weights को जो आप weights अपने आप modify होता है, right? Everyone agrees, right? That gets distributed, right? So the depending on the loss, right? If whatever you have calculated, right? That gets projected through the layers, right? So if I talk about, they are parameters. What are the hyperparameters? Hyperparameters is the opposite thing. Things which are tunable by humans. We have control over it. Like, for example, if I talk about the vocabulary size is a hyperparameter. Maximum sequence length T is a hyperparameter. I can, in theory, make this sequence length T as 8K as well. I told you, right? GPT-2 has 1K. Tokens. What do you say? उसको क्या बोलते हैं भाई? मैं word बोल के मैं खुद ही भूल जा रहा हूँ. That is the context window, right? So yeah. So we are taking here. So this is GPT-2 on the left-hand side, by the way, right? So the context window we have kept here as 1024, right? If I talk about, right? So this is, so moral of the story is, let me write it down for everyone. Parameter, right, gets changed, or I should say trained, I should say automatically during, or changed, trained, or updated, whatever you call it, right? During training, okay? And hyper parameters are nothing but things which are made static before what do you say before you what do you say before you run the network, right? Before running network, right? You got it, right? So these are called as hyperparameters, which are static. In fact, in all the context, whether you are referring to machine learning, deep learning as well. So in deep learning, what could be a hyperparameter? Like the hidden, I mean, if I talk about, right, the number of layers which you are talking about, that is a hyperparameter, okay? Learning rate, you fix it, is a hyperparameter, right? So I think you can understand, right? But on the other hand, parameters get trained during the course of learning process. सबको समझ में आ गया? Yes, no, maybe. Just like how Aziz sir and Raja sir have iterated. I hope that's particularly understandable by everyone, right? Perfect, perfect. That's great. Awesome. Now, let's talk about. So you can see all of these, right? You have max steps, meaning number of iterations or epochs. You are running it for 32,000 epochs, okay? So that is a hyperparameter, right? Validation loss, you can call it as a hyperparameter, meaning I want to see the validation loss after every 250th epoch. You got it, right? So validation maximum number of steps. You want to show the validation steps, right? After every 20, that could be a hyperparameter, right? So generation, gen t is number of tokens you are generating. I'm saying here as 256 number of tokens I'm generating, meaning after you have trained the model a little bit, you want to generate 256 tokens. Is it understandable, guys? Understandable? Yes, no, maybe. So that you are looking into, you are looking into, okay, how are the completions after every iteration, right? You want to see the progress, right? How it is happening, right? If I talk about, right? So all of these are hyperparameters, right? In the context here. So wait init method, again, you are randomly initializing the weights, right? So that is again a hyperparameter. Maximum sequence length, T, right? If I talk about vocabulary size, again, a hyperparameter, right? Depends on what you have taken, right? You could have taken 100K as well, right? You saw that, right? So I think you can understand, right? So padded sequence, right? So guys, you know, look at this number, okay? There is vocabulary size V and there is padded vocabulary size something here, VP, okay? You know, the reason why padded sequence are added is to be consistent with the numbers. Like, for example, so what you do, you take dummies, okay? You add dummy sequences, okay? These are not real tokens, okay? They only add, what do you say? You add dummy sequences so that this number, guys, if I talk about, right, I think if I talk about, right, these numbers become pretty much easily a factor or a exponent of the 2's, if I talk about, or the exponent of 128 in the context here, right, in the context window, right? So you make it so that, because I think you can understand, we have already discussed in our neural network classes and stuff, right, that when the architecture is closer, or I mean, if you make it using exponents of 2, right? If you have that many number of hidden layers, right? It tends to perform. Ideally, you can take any number of hidden layers, right? I mean, in a particular sequence, right? But it is generally taken in the what do you say, exponent of what do you say, 2 in the context of, so that we have that contextual window to talk about, right? So I think you can understand the context here, right? The maximum number of layers, 48. Number of heads, I think you can understand that QKV head, 25. You have channels. This channel is nothing but embedding dimension. Okay. What is the guys? I repeated it several times. What is the dimension of GPT-3? Remember? How many dimensions it existed in? Embedding dimension, GPT-3. I told you about
10,200.
12,000, sir. 12 to 88 or 12K. Yeah, exactly. So same way, Brilliantly said, sir, right? So for GPT-2, the lower variant, right, had, the higher variant had 1600 tokens, right? But there were, the base model of GPT-2 has 700 roughly tokens as well, right? If I talk about, right? So I think more or less you can understand, right? Training number of batches, 32,000. You can see all of those, right? And you can see here, guys, look at this, pay attention to this stuff here. Can you see that? What does it say? Number of parameters. These parameters are nothing but number of trainable parameters are 1.5 billion, right? You saw my earlier slide, which contained 1.6, right? This is the roughly the equal number of parameters which we are talking about, right? Roughly, if I talk about, right, in the context, right, it is roughly equal to 1.6 billion parameters, right? Do you understand, guys? Everyone understood the context here? Number of parameters which you are passing through is this. Is it understandable? Yes or no? Everyone clear about it?
Yes, yes.
Perfect, perfect. So I think, and now guys, there is one important thing, like suppose suppose some fine day that we cracked our head and all of a sudden we see that, we think that let's create GPT-2, right? Let's see what goes into creating this GPT-2, by the way. Can you see the device being used here? Look at this, the device being used here. Do you know what this is? A GPU, by the way, right? If I talk about, right, in the context, right, the graphic processing unit, if I talk about, right, you are using NVIDIA A100 series of GPU. Okay, you know, this particular GPU, each of the GPU, okay, each of this is 10 GB of, what do you say, graphic memory it has, okay, and you are having 8 of them to what do you say, train this model, okay? You are using 8 of the NVIDIA 8 A100 GPU, right? If I talk about, right, in the context, right, which is huge intent, you know, one of it, right? I think NVIDIA A100, if I talk about NVIDIA A100 10 GB का जो variant, I think it will be price. If I talk about, it is very high pricey. If I talk about, can you see these guys, right? You can see the price of it, right? So it's close to 16 lakh rupees, right? If I talk about, right, and in the context there, if I talk about, right, that's the extent of graphic memory which you are using just to train, what do you say, the oldest model, if I talk about, right? And if I talk about the T flops means teraflops per second, or what you say, number of floating point operations it can do. 312 into 10 to the power of tera is 10 to the power of what is it? Basically trillion. Tera is basically trillion in this case. So 10 to the power of 12, right? So 312 into 10 to the power of 12 floating point operations. What is a floating point operation? Like any of the summation you do, like, or in fact, let's say 300 multiplied by 4, if you do that, that is, what do you say, floating point operation which you are doing, right? So if I talk about, right, so that is a huge bump which you are expecting in the context, right? The amount of resources, right? Can you guess, guys, right, how much, given this resource, right, and given GPT-2 in its ounce, right, how much time do you think, right, how much time do you think it will take for you to train that 32,000 batch, given this resource, this big amount of, giant amount of resource, right? And each resource like approximately 16 lakh rupees, right? If I talk about, right? And you are spreading it across 32,000 batches, right? What is your guess? How much time do you think will it take to create or train the entire GPT-2 series of models? How much time do you think? Any approximate number would suffice. सब सो गए? Anyone there, guys?
Yes, sir.
1 month.
1 month. Okay, nice, sir. Nicely said. Yeah, and thank you, sir. Aman, sir, you unmuted to say something. Aman, sir, any rough idea? Whatever. Sir said 1 month. That's nice. One of the guesses.
You were asking about precision or
No, how much
which-
time do you think will it take to train this? Given this huge amount of resource, I've already expending a lot in terms of the resources and stuff, right? Yeah, and running these many, because this is the total number of batches or epochs through which it is going to run. Okay. So if I talk about, so it is going to 1, 2, 3, 4, so and so till 32,000, right? If I talk about, right? So how much time? So sir says 1 month. What is your take? How much time? So basically what it means is, how much time do you think it will take to train GPT-2 model in this configuration? What do you think? Any numbers? Any numbers?
like 30,
30, what's it? 30 hours? 30 days? 30
30
years?
seconds.
30 seconds. Okay. Okay, nice, sir. Okay. Uh, actually, sir,
I saying so fast.
both of our sirs have given extreme points. I'm very happy about it. You know, even with this big resource, big chunk of resource, it will still take 3.5 to 4 days to train GPT-2 model. This huge amount of resource, consider that you are running it 24 hours and for 3 days or 4 days in total. So if you talk about just GPT-2 model, okay, which is containing how many parameters did we say? We said about 1.5 billion parameters. GPT-3, you remember, right? I told you has 175 billion parameters, right? Which is roughly equal to how many times? I think more than 10 times, right? GPT-3 is having more than 10 times, not 10, it is 100, right? I'm sorry, guys, right? 1.5 multiplied by 100, it's 150, right? More than 100, right? If I talk about, right? Everyone agrees? So it will, so I think you can understand, given this set of configuration, it will take 300 days, 300 days for GPT-3 to get trained on. And that is why you might have seen that there was almost like a year gap to release GPT-3 when they released GPT-2, if I talk about, right? So if I I mean, this is a state of the art, what you say, GPU device, which is available if I talk about, right? Or nowadays it is way more easier because, this guy, Elon Musk, he is trying to create a GPU farm where he would be, he's planning to keep like 1 lakh GPU units parallelly to do some tasks. So I think you can understand that you are just using 8 units here. So if it is 1 lakh units, right, the thing is subsequently cut down, right? So he is doing that just for taking what you say, just for advancing AI in the perspective of what we are talking about. Okay. So I think, guys, I would rest my case for today. Okay. I know it's been already a long time. Okay. So, and by the way, these are the few things which you can see here, right? You can see some of the memories getting allocated, right? So you have 3 GB for model parameters, 4 GB for activations, right? Allocating 3 GB again for parameter gradients. So look at the amount of memory it is consuming, right? Our systems generally have 8 GB and 8 GB is used. उसमें भी हम अपना application चलाने के लिए it is like it is dead, right? But the kind of allocation it is doing in the context here, right? for the context which we are describing here, right? So it is just a snapshot about how GPT-2 looks like. If you want to train it from scratch, it is possible, right? There are, the fun way to actually talk about it, right? You can actually, you can do it, right? You can purchase some of the, because this is not feasibly possible, right? It is not possible for you to buy such hardware, right? Obviously, you can't buy 10 GPUs like this. You will be bankrupt, right? We will all be bankrupt by the time you buy it, right? Or we buy it for the context, right? So what you do is, other option is you rent out GPUs, right? So there are GPU services or cloud GPU services, right? So we'll look into those as well in our subsequent sections, where I'll little bit talk about those as well, okay? And you can rent out, like hourly you can rent it out for $1 or $2, and it is so for 3 days it will be roughly around, if I talk about, right, that much amount. So 24 into 3, so somewhere around $100 you can be done with. You can train your GPU and stuff, right? You can rent it out, right? So that is possible, right? If we talk about, and that is how the companies like OpenAI and I mean, if GPT, if I talk about OpenAI, to when they developed, right, they used cloud services, right? It is feasibly not possible to run it on a local system. You can see the constraints here, right? Especially the state-of-the-art models now releasing nowadays, right? They have billions and trillions of parameters, right? Llama model, for instance, has 408 billion parameters. So imagine 3 times that of the GPT-3, right? So it is 300 times the resource requirement here, right? So I think you can understand, right, roughly around in the context, right, which we are talking about. It's a rough size, a rough estimation which I'm giving, not exact stuff. Okay. Now, that's it for. Sorry, sir.
हाँ सर, जो भी बनाते हैं सर हम लोग मिलकर ट्राई करेंगे.
हाँ सर बनाते हैं, सब लोग मिलके एक फार्म बनाते हैं सर. तो उसके बाद हम लोग will do that. Sir, Elon Musk का बड़ा अच्छा है सर. He has a lot of money and he can buy farms of GPU. He's the world's wealthiest person, right? I think he's even 3-4 times richer than the second wealthiest person in the world, right?